Alright. Alright, I'm back. Welcome. So, yeah, I'm currently building this game editor here, and I'm currently working on the upgrade document things. Like, yeah, we have a bunch of documents in the application, and they can represent things like entity types, scenes, time maps, animations, textures, but yeah, the upgrade document only applies to, well, I guess it could technically apply to the texture document as well. But it's basically a way to fix any breaking changes between versions. So if I update how I want the underlying data to be stored, we need to sort of migrate to the new type. I mean, it's like data migration. Like, if you're familiar with databases, you have a schema that defines what sort of types of things that you have, and what the types of fields and stuff they have inside. But then if you want to make a change to that schema with an already live database, you have to do some migration for that, which usually is like either you add a new field, which is pretty easy, or you could, because then you just update every row with that field, or you could delete the field, which is also pretty easy, or you could change a field to something else, which is a more tricky, I guess, well, depending on what you want to do. And right now I'm encountered a breaking change of the tile maps that I have, going from a 1D array to represent the tiles to a 2D array. And since I already have a bunch of tile maps, I'm kind of in this situation, so that's why I'm doing this upgrade stuff. And it's kind of interesting to explore how to do this. So right now I'm working on like upgrade versions, so each type of document will have its own sort of migration or upgrade like logic to it, which makes sense because it's kind of like its own thing. So let's see, I mean, I guess technically in the future we could have stuff happening like between documents as well. Like you could have, let's say, a tile map does not reference a texture anymore, as its tile set is gonna reference a tile sheet instead. So then we have to change. Then that's gonna be a migration that's gonna happen like across different types of documents. So that's gonna be interesting. I think that's probably gonna be more like a application-wide upgrader or migration logic instead of per document. So actually, maybe I am painting myself in the corner here. Maybe it's better to keep the whole thing as a section of version that we just upgrade everything to, because then it's easier to see that everything, you know exactly how everything was before and how everything will be at the next version. That's actually a good point. I mean, I guess we could always change it later. Like, if we encounter that problem, we can change the upgrading version. We can still have, maybe try to utilize what we already have. It's a little bit tricky. Yeah, I think it probably makes more sense. The reason why I did like this is because we don't really have a version of the whole application yet. It's like very still in pre-alpha or whatever you want to call it. It's like it's not even meant to be. I mean, it's unclear if it's even gonna be something that's gonna be released or something like that, you know. But I'm just trying to think, like, if we have this system, would it, like, and then if we encounter this issue, maybe that's when we start with the versionings of the program, and we do an upgrade that's gonna be like for the whole program instead. So then maybe we could keep a version in the project instead, and then upgrading from the old project to a new project. Yeah, that makes more sense. But it's gonna be sort of the same. We could reuse a lot of the same logic around surrounding the thing. I think I'm gonna keep it like this for now because it's easier to think about one document at a time. But yeah, and also we don't really version the project yet, so. But yeah, let's continue here. So yeah, so last time I did a whole bunch of like things surrounding the upgrade, like implementing the upgrade system. I've not yet implemented a specific upgrade that we want to have for the document that has the breaking change, but I've just done like the surrounding sort of framework for it to actually work as I see it. So what we have is basically, I've basically built this abstract thing before actually needing it, I guess. But it's mostly because I've done this sort of thing before, and I had an idea in mind that I wanted to try. But I could have just, you know, done the upgrade. You know, what I could have done is just made, like I've done before, like just write a JQ script that automatically updates everything. But, well, for one, since upgrading a 1D array to a 2D array, I've never done that in JQ. I'm not sure. I mean, it should be possible, but yeah. But then I knew that this was probably gonna be something that we want to have, like an upgrade system. And also, since I already have like a bunch of tile maps, yeah, right now I have a bunch of tile maps, and I want to use the upgrade system to upgrade them. Okay, and it was kind of fun to build as well, and you learn a lot more about SIG also when trying to do this stuff. That's the wonder about that's like what I like about program is like you can conjure up some sort of thing, and then you can just build it and see how it works. And then if it doesn't do what you actually want it to do, then you know it's fine. You can just you still learned a whole bunch of stuff, and but anyway, let's just keep on going here. I think this will probably like revamp the upgrade system in the future, because I don't think this will be scalable to across different documents. But yeah, so we'll probably have a project upgrader instead of just individual documents. Okay, but anyway, so let's just continue here. And here you can see now we reached the point where all of these different types of documents, well, I guess it only says it for scene here, need to have this upgraders list. So if we go to a tilemap document or persistent data, you can see here we have upgraders. Oh, should delete that one. And we'll copy this. Scene persistent data. And we'll just put upgraders in here. Except scene doesn't have any upgraders. Okay, let's see what it says now. Indexing into empty tuple is not allowed. So I'm not sure why it even goes in here for scenes. Because we don't. Yeah, it's weird. So it's like weird because this thing needs to be more like positive. It's a U size. It needs to be positive and more than 0. However, we are asserting that this. So this is max of this and 1. So if this for some reason is 0, then this will be 1. However, this can't be 0 because we are asserting here that it's not going to be. Wait, it's not going to be less than 0. Actually, yeah, it's. No, current version should be more than 0. Yeah, that's what it says. The current version should be more than 0, which means it's 1 or more, you know? So we shouldn't have to do this, but if I remove this and replace this with persistent data current version, then I get a compiler error saying that overflow of usize with value -1. So apparently it goes in here anyway, even if I'm asserting that current version is less than the first version. It shouldn't even get in here in that case. So maybe, because somewhere we have an if that says, yeah, here, if the value version is less than the current version. But what if we do this? Will it go in there then? Now the problem, the error went away. Interesting. Wait. Return final. Alright, because now this was like the current version, so we have to change this because I moved the location of this function into this one, and that's not the correct type, so we have to grab the latest upgrade. So let's just say latest version of, so it's basically we have a function called latest version, and then you have document type. And we get a type out. And so it's basically gonna be, well, this is gonna be like persistent data. Actually, oops, we already have like we don't need to actually do anything. We can just do const latest version is equal, like latest version document, like persistent data. No, it's just persistent data. It's just that's what it is. It's just persistent data. It's a pointer to a persistent data. Okay, but the issue here now, we have like, this is final. It's not actually persistent data. It's document 1, which is sort of like a, what do you say? If I show you, I'll show you document persistent data or time map. Let's say this one, for example. So here is like the current version of the time map. It looks like this. So it has version, ID, time map, history. Now document 1, the version 1, which is the same version as this, looks basically the same, but all of the things inside here are actually not aliased with these things. They are like, if I show you document 1, it's like this. So we have, well, I'm not showing version here. We should have a version, I think. And so version, ID, time map, and I removed history because I'm not really using it right now. But version, ID, time map, and the time map, instead of it having this struct, it's just everything is spelled out basically. So and that's because we want to keep this struct. It's not, we don't want it to change. So we just hard code basically in the entire thing in here, and so that way the version, when you read in the JSON of this, and you read in this version, if we have changed the current version to something else, like we changed grid or remove grid, or we change, like we add stuff, like it's not gonna match anymore. So we want to keep this frozen, and then when we read in the JSON of the old version, we want to read in this version of version 1. If let's say we have version 2 now, so we want to upgrade version 1 to version 2, well, then we read in this version, and then SIG will know, okay, this is how version 1 looks, and we can read it in, and we can do the upgrade, and now we have version 2. So that's the idea there. And let's see. And so we shouldn't so this version here is like the final version here. Yeah, this is the final sort of mangled version. Or it's not mangled, it's more like, I don't know, frozen version or whatever. So it's not exactly the current version. It does have the same structure basically, so it's just a one-to-one copy, but it's a different type with small differences. So what we need to do is we actually need to also do a last step where we should have an upgrade. We should have like what you would call that, like we should have another function here that needs to exist on all documents, which takes final step in the upgrade, like the chain, which takes the current version that is frozen. So we don't really need to specify that because we already know what it is. And then we need to take we need to get that thing. So we'll get the document here, which will be, I mean, I could just hard code it to document 1, but it's basically going to be, oops. Let's see if, how do we do this? Yeah, this is document final. Let's just put this over there, over here. There we go. Okay, and now this is document final. Final. So we take document final and turn it into our current thing. So that is what we need as a last step. And once we've done that, I wonder if we can do this. Oh yeah, so I was trying to not make it a pointer. I'm just gonna grab a cup of coffee. So how do we... Right, let's say we have this. So it's not actually a pointer, it's just this, okay? But then we can't do that, we have to have... Oops. Okay, so this is just to do that. Okay, it's still unknown because it doesn't know what this is. Okay, but just to, like, you know, I'm saying that this is the result I want. Is it the result that I'm getting here? So just as a safety measure there. Okay. And then we destroy the loose pointer there, and now we have it as a copy on the stack or whatever. And what we want to do now, so we want to not return that. We want to return persistent data upgrade final. There we go. Now this one is complaining it wants a pointer. Okay. So it's not a pointer, it's just the persistent data. I'm not sure how this, well, it's an opaque pointer, so I guess it's fine. Root source, file struct, document, title, upgrade 01 is no member named upgrader. So you get these nice error messages that says, okay, it's not called upgrader, it's called upgrade. And you get exactly which file is wrong. So you do get, even though it's like generic and sort of code generation and stuff, we do get compilation. Yeah, we do get the compilation errors, so it's really nice actually. Even though the LSP doesn't really work a lot with comp time generated types that are more advanced than just a function returning a type that is like this generic, how generics are usually made in Zig. As soon as you have something more advanced than that, then the LSP just gives up. But and you get this unknown. But it also makes sense that it would be unknown here because it could be one of several types because it's generic. So we don't really, but I mean, technically you could have a union type, I think, or wait, is it union? Yeah, I think it's union type. And I don't mean like union as in Zig union. I mean like a type that can be one type or another type or whatever type. Okay, so this says I need two arguments. Yeah, I need an allocator. Right, so it says here expected. Okay, so we need to dereference. Fine. So we're dereferencing that. We're destroying current. Should we destroy prev instead? Because that has like the correct alignment and stuff. Because yeah. Let's do this. Final pointer. Oh man, one short of that. Maybe I should break some stuff into functions here. I don't know. And then the final is just gonna be final pointer like this, and then we destroy the final pointer instead. I don't know if it's gonna make a difference. I mean, the pointer should still point to the same. The pointer is, I mean, a pointer is just a U64. It should still point to the same place, I guess. I'm not sure. Maybe I don't know if Sig maybe has more information. I mean, you have alignment and stuff, but I don't know. Okay, I'm just guarding myself a little there. Value of view size ignored. Okay. Right, so that is like the latest version or whatever it's gonna be. I don't know. Okay, what kind of errors will pop up now? Value ignored. Yeah, okay. So now this returns the actual data itself. So upgrade potentially already creates the persistent data. It might not, because the thing might actually already be upgraded. So here we return null, and here we return this result. So let's change this to a nullable persistent data. And here we should also return this. But now we get into this error here. So somehow we get in here when the current version is 0, which it is for basically everything that is not a tile map. But why would it? So if it's missing a field, we go in here. The first document version is 0. And the current version is 0. So we're asserting here that the first document version is less than the current version, which implies that current version should be more than 0. So this is like this weird thing where the compiler goes in here even though it shouldn't go in here. Maybe we should like upgrade. I mean, this just makes it more feasible for the other solution where you have a project-wide upgrade instead. So upgrading like basically all the documents. I mean, it does make sense to have document version as well. Let's say someone wants to share a document to another project. Well, I guess you could include the project version at the point of sharing, but let's say that you just copy the files, because that's going to be possible. Perhaps. Well, you copy the file, but then you also have to copy all the references as well. So it's not going to be that easy, but you just do that. Let's say you have a version in the document, it can also get upgraded. However, let's just say that that's not a supported solution and we just make a share feature in the project instead. I don't know if people are gonna do that, but it's not okay. I'm just dreaming here. Is what I use as a term for making up scenarios in the future that's probably not even gonna happen, you know, and we probably don't even need to consider it right now. So what I'm gonna do is but it's good to, you know, do the exercise, think about the future, so you don't paint yourself in a corner. Another way to do it is just like I could have, as I said before, I could have just, you know, made a script to make it work and use that philosophy through the entire thing. And as I said, there's also like pros and cons with that approach as well. I'm not gonna die on any hill, you know. I'm just learning and doing stuff. Overflow of integer type usize with value -1. But I'm not gonna say that's one way is. I'm not gonna say one way is better than the other. Basically, is what I'm saying. Using, yeah. So how would we fix this? Well, one way to fix it, just set every document version to 1, I guess. It's probably better, it's probably good to keep them at the same version. Well, actually, they should have an upgrader because every document should have a version now. So that's a difference. So actually, yeah. Okay, let's just do that. So how do we do this? We have upgrades and versions. And then in versions we have 0 and 1. Okay, let's open. Okay, this is, well, we don't need standard library actually. This is a list of pointers to a struct. Which is this. And the vector. I have seen entity type. And this is gonna be interesting. It's good that we changed this to custom types because we're gonna have like a million different types to worry about here. Oh man, properties. Properties actually maybe one thing that we wanna also version and keep separate maybe. I'll just put it here for now. I guess we could have like properties here instead. Okay, now this one. Okay, I'm actually gonna use standard library. JSON array hash map. Because it is a string array hash map, so, and then this is a property. So we'll add a struct. Type. Property object is probably 0. Actually, this is property object. String. Actually, you know what? No, it's. I was thinking if the string should be serialized, but they don't really have any serialization, and we might also add more stuff like max length and stuff like that. So it makes sense for them to be objects. This doesn't need to be public right now. And entity reference. Oh, document tag. Yeah. And I'm just when I'm doing this, copying this stuff, I'm just questioning if this is the correct way, if this is a good way to do it. It just feels like so much. I don't know. Entity exit. Wait, oh yeah. Well, like if it's null, I guess. But this one is just. Okay. All right, that's our whole thing. Basically, all the types in here needs to be either types referenced from this document or just primitives, or close enough to a primitive like the UUIDs, and basically things that shouldn't change between versions at all, ever. So that's version 0, except version 0 doesn't have this. Yeah. So that's okay. Let's do this. Let's copy this. Oops. And we'll paste it in, and this is the version 1. that's version 1. Version 0 should remove version. Right. And then, and in the future, let's say we bump a project version and we implement the document version, we could just set the next document version to be the previous document version if nothing changed. And we should probably keep, you know, things like this, project property object 0, this should probably be like a global thing instead of in here. So all of this is gonna be like in its own thing. And also this, of course, this one is even more global or shared between things. The document tag. Okay, so there we have our stuff. Now let's copy this and go back here to upgrades 0 to 1. Yeah, and we don't really need to change anything in here because it's all done already. What we can do is make a sort of generic logic here, so that because that's gonna be copied from between all the documents. We're just gonna add the version. So basically, we just do this and say that the version is 1, and then entities, we just gonna actually, you know what, let's do var next equals previous. Oh no, we can't do that. Now we have to go through each one. I mean, we could make a loop, I guess, with I wanted to make it more convenient, but okay, is that it? Okay, so that's it basically, and we don't need you. There we go. Now this could be copied between all the documents. The only thing that we need to make a better version, another thing is with the time maps, because yeah, here's what we actually need to upgrade: the 1D array to a 2D array. But let's do the same thing for the other documents. Let's just do take animation, for example. So we need versions and upgrades, and we're going to upgrades first, 0 to 1. There we go. And now we need to implement these. So we need 0. Now here we need let's go to, I mean, we can just go up and go here. So this would be document 0. Okay, I'm just gonna call this like animation 0. See. Alright. Animation is over here. Name is a string. Frames is a list of frames. Vector is vector. Alright, now we need frame. It shouldn't be too bloody here. There we go. and we're done with document 0. So let's copy this and we'll go into 1 and we'll dump these zeros there. Okay. And we also add version. There we go. And if we go back to the upgrader now, it should all work. There we go. Except for this part where we need to fill in some other stuff. So let's go previous animations, texture ID. There we go. All right, that is that. What else do we have? Oh yeah, also I think we need to, what if we go in persistent data, we need, yeah, so we have upgrade document. We also need upgraders. Wait, do we not have upgraders? Oh, yeah, we don't need upgrade documents. We need upgraders. There. There's the upgrader. What else do we need? These things. Okay, we'll try to figure out. This is going to be the same for everything. We'll try to figure out what the upgrade final will look like. You also have, okay. It might look the same for everything. I don't know. Unused. Oh yeah. So, well, let's say we do this. So let's do return this. We have version equals. That should be fine. Wait. Why does it think this is a type? Okay. What else do we need here? Texture ID animations. Texture ID is just a UUID. Yeah. We could probably have like an automatic thing that automatically goes through each property or field and populates it and checks, okay, is it a primitive? Then we just copy it. Is it a list? We create an array list unmanaged. Is it, yeah. Well, let's do it like this for now. We only need one version of this function anyway per document, so it's not that big of a deal, I guess. It is a little bit involved because you need to convert all of the stuff into array lists. Like if it's just a slice, we need to convert it into an array list. Like for example, animations here. And also the things inside, which also has an array list of frames. And this needs to be initialized to a string Z. So there is a little bit of stuff that has to happen here. So we have like animations. I wonder if there's like an easy way to access sub type, like fields in a type and get their type. Field type. No, animations. And we return our current version. We also probably need we need an allocator. Okay. So we need to create an array list. Which is this? Just array list. That we return. Okay, and then I guess we just look through the animations. And we append upgrade animation. Let's see, this will be let's do init capacity, animations length, yeah, and now we need upgrade animation. Wait, this is not a list. Document find animation is gonna be document find animations. Dot. Wait, how does that work? So we want the element of this. Yeah, that's the animation. Okay. So this will be final animation. And we will return a normal animation. All right. Let's do this just in case. Okay, frame duration, animation, frame duration, grid size, frames. Oh man, great frames. Now we could. I want to try this. Okay, let's try a little bit of generics here. Upgrade list. Okay, so it's basically okay. I'm gonna do this. I'm gonna copy all this because this is gonna look the same for everything. Basically, I think I'm just gonna try it and see if it works or not. Now we need a type, so we need, or actually we could just have the sliced hair. And the resulting type, what do we know what the resulting type would be? I don't think so. So we have to do results. I guess this could be like result element. Because this is then gonna be an array list of the result elements. I'll just call this T. And then we can actually assume that this is just a slice of T. No, it's not a slice of T. It's not a slice. But it is a slice to something. I mean, I think we can do this. And then now we can create the list with these. Now we do slice.length. We could assert that it's not a slice, but I'm not gonna do that. Is there a thing like no. Okay. Maybe there's like a built-in. I know there was some convenient stuff that was added, but I'm not sure. Okay. Anyway. This will loop through the slice to get the elements. Right, and one thing also that we need is we need an upgrade element function. And so this is a function that, well, it's a function that takes the element and returns a T. Basically, it also takes allocator. Is it a pointer? I'm not sure. Upgrade elements. And that's basically it, but because it's gonna be exactly the same. What you could also do is make maybe an iterator or something like that, and then you would get a result at the end. I don't know. But yeah, now instead of calling upgrade animations, we could call upgrade list, and the element is an animation. That's the result. Allocator, and with the slice, and then upgrade animation is the function. Should definitely have allocator in here. Alright, and now we don't need this. There we go. We just need yeah, and then we can put upgrade list into basically its own sort of upgrade library, something like that. Actually, I don't know if I need allocator. Actually, it's frames, and then the frame will be element. Frames. Or we could just do frame equals this. No, but that's actually an interface. These functions should all look the same. Upgrade list. So we do need to pass in the allocator here as well. Alright. So actually no more errors in here. Okay. Well, let's do upgrade library and put this in there. No, I don't need lib. Okay. Public, and let's go to lib, and I think I want to do upgrade here. Actually, this is just import upgrade like this. There we go. I mean, it's basically turning a slice into an array list and also transforming the elements with the map function. That's basically what we're doing here. Okay. But it was yeah, it's a bit involved, to say the least. I'm not sure if this is like scalable, really. At least you only have to do this once per document. And now the thing that we need to, so we need to like change this whenever that document sort of changes. We need to also update this. We need to update the document versions. We need to add a new version. We need to add a new upgrader. But if it's most of the time, it's probably just like a trivial upgrade anyway. So it's probably, but it is gonna be. It's probably not really good timing for this system, but it was fun building it. And it makes it a lot more robust if, let's say, someone else wants to use it and suddenly a new version is out, but your program crashes because it can't load the document because it's an old version of the document, and so you're stuck there. You have to redo the entire project. Well, yeah, well, now this should fix that. So, but it just feels that I've built this giant backpack that I have to carry around here for all these documents. But and it feels almost like, if let's say we keep everything, so if we keep to strict rules regarding the documents, we could automate this entire thing, I think, except for the actual upgrade that needs to be done. But like this whole thing of shuffling around fields to different types, if they are the same, then that's like, it feels like, yeah, maybe the solution is just to make more of these upgrade things, like upgrade object. Like let's say we have a generic thing called upgrade object. Let's just toy around here. So let's say we want a result object type. Possibly we need an allocator. We need the original object here. And then we need like a map, a comp time sort of map. Yeah, we need like upgraders. For each element that is not a primitive. So maybe a map from types to, ooh, maybe like dependency action system. Well, now I'm dreaming here, like a little bit. But you could technically have that. But so it doesn't need to be like in runtime, it just needs to be in comp time. I mean, dependencies should be perfect for this. I'm just not sure exactly how to build it. I'm thinking maybe you have a container where you can register types to functions that upgrades them. Yeah, because we should know both the original type and the target type. So you could technically, let's say, I mean, okay. It's like a fully comp time struct. Is there like a comp time array list? Or like a... Okay, hang on. Zig comp time array list. I mean, you could just use append. I mean, it doesn't. I guess it doesn't really have to be comp time. Maybe it's gonna, but it's gonna be a map of types. Comp time. Well, okay, comp time map. Static comp time string map. There's no insert method. And I know also, I think the comp map, is this like old? What was I thinking? No. Hash map. Well, let's just take anything here. Array hash map. Auto hash map. Auto array hash map. Something like this. There should be some init function somewhere. No. This one. This one. It has like a slice here and a slice here, but the issue here is like it's like a, I think it's like a one-time thing maybe. Also, you need an allocator, so it doesn't really work. But maybe we can use a list. Maybe we can just use a slice that has a struct. So it's like upgrade type. I'm not sure what to call it. So you will have from type and to type, and then you would have a upgrade. Well, actually, this is allocator and well, this whole thing is like a comp time thing. Allocator, we need from, and then it spits out a 2. Okay. I was just thinking like a lot of different ways to do this. Just trying to figure out how you could do this in a good way. So I'm thinking you can have a function that matches, like does some comp time matching stuff on the type. But you could define a struct that has all the types defined, like animation, and then this, or let's say you have a function called upgrade animation, and then you take an allocator and you take from. So they all look the same. It's a from, and then the from is like animation 0 and 2 is animation. or I mean, it will return an animation. So if we keep to this structure for all the functions, then you can have an automatic selector that selects the function if the type matches on the from. So you could check, okay, is the from what we need here, and is the to what we need to produce? Then we can grab this function. It doesn't really matter what it's called, but what matters is the signature here. And we can select that function from the container to use, and then use that to upgrade for everything that is not like a slice or a primitive. You check here to see, okay, do we have an upgrader in the container for it? So this could be, so you would create a container for each of the documents. The problem is though, you would probably want to merge containers as well. Well, you can do that. You can just use pub using namespace for that. So let's say the final like container would be for each document. And then let's say you have things that are shared, like say property object. You could define that somewhere else, like the property object container, property object or property upgrade container. And you could then supply everything there that you need for property objects or properties. And then you create an upgrade container for each document. And if they need property upgrade container, they can use using namespace to import that into the container. We could do that, or we could just do that the upgrade thing accepts like a list of containers, so it would check each container for stuff. That could also be a way to do it. If, for example, if using namespace gets like deprecated and is not available anymore. So now in theory, let's say this returns a resulting type, and let's say we have a container that we pass in. Now we can go through each field of T because this is like a generic object upgrader, which could be used. So we could do it like this. We're using the generic object upgrader because that doesn't know if, like, let's say you add a field or let's say you remove a field or something like that, then that doesn't really know. Well, I guess if you remove a field, it could automatically just delete that field. But if you need some sort of special case for an object, then you supply an upgrader with that object from and to. And so when we do an upgrade on anything, we first check, do we have an upgrader for that type? So actually, let's do that. Let's do function upgrade value, I guess. And this is the resulting type that we want. We want to supply an allocator, and we want to supply the source type, this other source thing, and we want to supply container. I guess you could have like a merged, like let's say merge containers. Actually, you know what? Const container. Actually, this is a function. Function container. No. Yeah, no. It's a struct. Let's say a container is a struct. It has containers inside, which is gonna be or upgrade upgraders or something, I don't know. This is a list of basically any type of struct, like objects. No, I don't think you can use any type like this. It has to be like a pointer to any cake or something. Could it be a list to a pointer of any cake? I mean, it really doesn't need to be. It doesn't need to be. It just needs to be a list of types, I guess. Yeah. And then you would say get upgrader. You would supply. So what you want to get out of this is the function. But what would the result type be in that case? Maybe we just supply, maybe we just do upgrade. Try upgrade or something. This is the result that we want. And so result. So actually, let's do from. I'm not sure if we need both. We probably do. Actually, we don't need from because we already have from. To from. Okay. And then this would return nullable 2. Okay. Right. So now we need to find an upgrader. So let's, I guess we'll loop through the upgraders. We need self as well. Now this is probably gonna be like an inline. Yeah, so I'm not sure, but now this is a type. So it's actually a container of functions. So we need to loop through the declarations of this. Okay, now we get a declaration. We don't care about the name. We know that it's a function, so we can assert that it's a function. Wait, can we only get the name? What is this? Is this not possible to do? Well, maybe what we could do is we could say, so we have a name, we can maybe we can access the function by using field upgrader and this. And now we should have the function. I think. Maybe. I'm not sure. And then can you, how do you get declaration info? What is that? It just gives you a declaration which only includes the name, so what is this? Returns decal. Right, so maybe it does work because I see here that we're doing sort of the same things. Declarations. But the question is, how do you get like the parameter like, okay, maybe I need to get the type info. So we have the function. Now let's check type info of that function, or type of this function. And it should be a function. Here we go. And we'll check the parameters. So function from is gonna be this. Function to is gonna be the return type. Wait, param type. It's nullable. Okay. Well, let's just assume that it exists. Okay, so we have the function, we have function from, we have function to. Now we just need to match if from is equal to type of from and function to is equal to. If that is the case, then we have a match and we can return function applied with allocator, which we also need. Allocator and then from. Okay, and then but if we don't find anything, we return null. Alright, so we have a way of defining a container that has a list of sort of sub-containers that you want. So basically this is a, well, it also has try upgrade, so it has a matcher as well. But basically this is a merged container now. So we can take a whole bunch of containers, put them in a list, then we have a try upgrade function that where you can supply a type that you want to upgrade to, the allocator, and the thing that you want to upgrade, the value that you want to upgrade from, and it returns a maybe a 2. And so we go through each upgrader, we try to find we go through all the declarations of that type. We try to find a function that matches this, that matches the same thing that you want to upgrade here. And if we find it, we're gonna use the function and return that. And we probably should also support errors, but I'm not gonna deal with that right now. Okay, there's probably like a lot of errors in this code, but let's say the container is actually a container now. So that's really nice. We can use that. Now, here we basically say, like, let's say we have to try the container first. So if container try upgrade to allocator source, we get the result and we return the result. So if we get a result, we can just return it. Okay, otherwise we have to do some type matching on the source. So we have to like check if it's a primitive, then we just return the primitive. If it's an object, we have to use upgrade object. If it's an array, we have to use upgrade list. So yeah, I think what we're gonna do is we're gonna check type of source type info if it's a pointer. Why am I not getting? Like it says here it's a pointer, so why am I not getting auto completion now? Okay, whatever. If it's a pointer, we need to check. Well, if it's a pointer, it's basically the only thing it could be is like a slice. So if it's a pointer, we do return upgrade list. Now this is the element. So this would be child. Okay, now we get it. Allocator. The slice is source. And the upgrade function is going to be just upgrade value. Right? Well, actually it's not, because, well, yeah. So we need to modify this a little bit. I don't think we're gonna use upgrade element. I think we should just use upgrade. Let's do another version real quick of this. We don't use this, we just use upgrade value. Upgrade value, T allocator, source, and the container. We need to pass the container around, I think. Yeah. Okay. Otherwise we have a struct. We could also have like a union. We have to take care of some of these cases. I just need to BRB for a second here. All right, let's continue here. I thought that maybe I should explain why I'm doing this, in case I need to. So basically, I just noticed while I was doing those upgrade functions for each document, it just felt like, oh my god, this is so much work, and I'm gonna get a huge backpack that I need to carry around, and I don't really want that right now. It's not really such a mature project that you want to have that thing. So what I was thinking is, well, maybe I could make a more like generic upgrader. Well, I did sort of explain this before, but I was just thinking like, yeah, this is just to avoid having to have specialized functions that basically almost do the same thing for every thing we have. And so I'm just gonna add a special or a generic upgrader that works for basically everything, and as long as I keep to the same pattern on the documents, then it's gonna work out. And if I need to expand on that pattern or change it, then I can change the upgrader as well. So it's not rigidly, like, you could sort of accidentally not do the same sort of pattern. But I guess we could maybe have a test for that. I'm not sure exactly. It could lead to problems in the future, which could be like very hard to find the source for. But yeah, but I think it should be fine. Let's say we get a struct, and if we get a struct, I mean, it's a struct that we haven't got an upgrader for, so we have to use upgrade object. The generic version of upgrading any sort of object here. I guess we could call it struct, but I'm calling it object. Source and container. Okay. Now the object upgrader, we will do fields t. I guess we could sort of have automatic. We could have a warning that says during automatic upgrade of object blah blah blah, this field was removed. It's only gonna happen like once anyway. But that log is basically disappeared because it's I'm just logging. I'm not logging to a file or anything. I'm just logging to the console. That's actually something that we might want to have as well, like logging to a file instead. Okay, but anyway, so let's just cause an error if that happens for now. So we go through the fields, we get a field out here, or not. So what if it's this? Oh, that's the return type, okay. It's just info.field, so why aren't we just using that? Type info of t struct fields. There we go. Okay, and each field, yeah, so we need to create a result, which is t. Now it would be nice if we could just do undefined or empty maybe. No, we don't need it because all the fields are gonna be there, I hope. So we'll do field on result, field of name, it's equal to field, well, it's equal to upgrade value of, so okay, now we need like field, okay, I guess we have field type, the allocator, the source is going to be field object field of name, and then the container, and in the end we return the result. So that's it actually. That wasn't too bad. Well, we've yet to see any other compiler errors here, so we might open up a can of worms soon here. So upgrade so we don't really need this struct, we just need to know if it is a struct. Oh, it formatted. Now let's say we have some other stuff. If it's an enum, it's just a straight up copy, I think. But let's say there could be different versions of the enum. So if it's an enum, I think we need to copy the name based, or we need to copy them based on the name. Upgrade enum to T allocator source. So we need upgrade enum. How would we do this? So T is an enum type. Now type of source is the, so to type of source, and no, not to, that's from. Okay. What about field? Can this access like I guess string to enum. We could do string to enum on so this is the result we want. The string is going to be tag name of source. Yeah. And we force it. So we don't really need that. We just assume it's a thing. Yeah. Okay, now we can have a union as well. Now we need allocator because we're gonna have to pass this into upgrade. Oh, we need a container as well. Because we need to pass this into upgrade value at some point here. Now, how do we do? I think we're gonna do basically the same thing almost like this, except we're gonna be using union init into this type. So it takes the union resulting type. We have the active field name, which needs to be comp time known now. So actually, we can't just take tag name here. We have to do like an inline for or wait, no, we can do switch on source and then inline we get the value and we get the tag, which is comp time, and then now we do union init t. Now this is going to be tag name of t, so now that's comp time known, and the init expression is going to have to be upgrade value to, I guess, what would the result be? I mean, let's say we have the result here, allocator, and the source would be v and the container, right? So the only thing we need is to calculate the resulting type. Now we can't just take type of v because that's like the frozen type. So what we need to do is take like how we do it here for the object, the resulting type, we take the original type and look at the field type. We should do the same for this. So it's basic, I think it's gonna be payload of t with tag. So we need the tag as well. So result tag. And this is also gonna be, I think, string to enum. Now this is gonna be the enum tag of t, because it's a union, so we have to take the tag that becomes the enum of that, and then the string is tag name of t. So now we should have a tag for this. So that's the payload here. Okay. But we also need to match the tag name of T and the tag name of source if they don't match, we have to continue. Wait, no, we don't. Wait, we get whatever is the matching tag here. This is the result. Yeah, this is the no, this is the previous. This is the source. Yeah. Oh yeah, so we get that. We match it by grabbing the result. Yeah, okay. So it's already matched. Okay. Now, is there any other types we need to worry about? Array, we're not really gonna have an array. I guess optionals? Yeah, optionals. Same deal here. We could have a child. Let's see. So the resulting type is T, and if the source is optional, T should also be optional, right? Yeah, they should each like match their thing. So T is optional, so basically we could check if source has a value. We just return upgrade value of that, and then we take like type info of T optional child. That is the resulting type. Okay, otherwise we just return null. Okay, what else? Oh, error, but we're not gonna have errors. Okay, enum union we have functions, we don't care about opaques, we shouldn't have frames. I don't know what frame is. We probably won't have this function. No. Any frame? No, I don't know. Vectors. This could actually be a thing, except this should be covered by the primitive. Yeah, so if we have anything else, it should be like a primitive. We assume it's a primitive. We don't need an allocator for that. And we don't need a container because we already Actually, we should just return. We should just. Yeah, we should just return source because, yeah, we're assuming it's the same type at that point. All right. Okay. So let's try and call this now. We need to. Okay. So let's go. We'll make this public. And this is public. Don't really need you to be public. Okay. Now let's go back. I mean, I guess here. And now we can basically just use upgrade. I mean, now we can basically, what we could do, we could just define upgrade container. There's going to be upgrade.container. And this is going to be that. So it's a struct that has upgrade. Let's say we do like upgrade animation, let's say. Or do we even need these specialized upgrades? The only thing we're doing is, oh yeah, string Z. That's one thing that we actually want to have an upgrade for, and the problem is that it's generic for the length of the string. Oh no. You know what? Maybe we can have a special case for strings and always. Because the problem here that is basically like in our sort of pseudo what do we call it, dependency injection system that we have for the upgraders, where we're matching the types and stuff. It works well for types that are not generic, but as soon as you have a generic type, then it's like, okay, what if I want to watch match all types that are string Z, but the inner parameter doesn't matter. Like I wanted to match everything there. Then that really, like, because let's say you have a string Z, upgrade string Z. I mean, I guess what we could do is define one for each, one for each capacity. But let's say we have this, and the first one is allocator. Then we have Actually, should probably pass in a container here as well, so that you can use that. Perhaps. Oh well, but let's see. Allocator, and then what is it? From, it's gonna be a string like this. Maybe we should define that as a specific type, so it's always the same. Like, I don't know, frozen string or something, I don't know. Then it's gonna, yeah, and then it's gonna return a string z. So this is the problem, like, if it's gonna match the exact type, then this number in here, we need to put in a number, has to match as well. But I basically want to match all of the numbers, so that it doesn't really matter. And maybe this is the time where we actually refactor string z so it doesn't take, because I've never actually, it doesn't really make sense in a way to have it there. Well, it makes sense in a way, in the sense that we have a max length that is now set, but it doesn't really need to be built into the type itself. It just makes it more cumbersome to use. Now, how many references do we have to string z? 22, so it's not really that much, actually. We could just change it. It's also going to change the string z array hash map, but we're not really using that much, I don't think. No. So I think probably we could do that. And we could actually just put that in the upgraded, like in the original container itself. Or we could say like, let's say we have standard container. So then when we create we will return container, and then upgrader is going to be upgraders plus standard container. So you can override it if you want. We have the standard upgraders. Okay, yeah, I think we want to do this, and then it's basically just return string z init format. Okay, and then we go here and we remove this. But now we don't have a capacity. So what would the capacity be? Should we just make the capacity something standard, and if for some reason we get over the thing, with format we reset it, we should reallocate to match the thing. Format, buff print error, no space left. So if there's no space left, we will re-initialize. Or if there's no space left, maybe we just, you know, yeah, that's the max, 256. You can't have more than that, maybe. Or you can manually maybe set the capacity if you want from outside. So if we catch this error, I think we will just ignore it. Maybe. Or log a warning, maybe. Maximum length exceeded. So hopefully it still prints the thing. Right, and then if you really wanna do, let's say, init format. Let's do like, I don't know, init format capacity. Okay, now we have to check. Here, for example, this is now could be just a struct. Same thing here, we don't need to worry about max capacity. There we go. Wait, is this used anywhere? No. Okay, I think that's everything we need to do for that. Okay, that's nice. That's really good. And now we can implement. Now, yeah, we have this default initialize or upgrader for this type now. I mean, it's almost like, you know, a kind of conversion, sort of like Rust to or into, or I'm not sure what it was called. I've not actually used Rust a lot, but I know there's like a trait where you can convert types into other types, and this is basically the same thing, except you need to, or into, I think is called the function that's called. But this, yeah, you need to pass around an allocator and stuff. So actually, when we do this, do we need to like also deallocate the original slice? Probably. I think so. We probably need to take care of it, because the old value we're just gonna throw away, basically. Yeah, let's do that. So this will be 2, and then we free from, so then we return to, there we go. Another thing you could do is keep the original stuff in like an arena, and then you just free it all, but I've used this pattern everywhere, so I'm just gonna do it like that. Okay. Another thing that we need to do is for upgrade list. Actually, this should be upgrade list 1. We also need to, because source or slice now is it's a slice, so we need to deallocate that slice. So allocator free slice, and we're done with that. There we go. All right. Yeah. So where's the upgrade stuff? Oh, over here. Wait, wasn't animation persistent data? Yeah, so this, so the thing is, I don't really think we need any special upgraders for this one. The only thing that these are primitives. The animation themselves, this is gonna get automatic. These are primitives, and these are primitives. So we don't actually, I don't think we need any of this. And so the only thing we need, upgrade final, we need to do, yeah, we just need to do like upgrade value into this allocator, and this is the source, and this is the container. And that is actually gonna be the same for all of these upgrade finals. So we don't actually need to we don't need to even do this. We can go to document generic, and where we call final here, we can just return this. This is final, yeah. And the result is persistent data. and the container is going to be persistent data dot upgrade container. So that's the only thing you need to define there. Now we need upgrade. Okay. So what we need to define is a list of upgraders. The final, we don't really need this. So let's get rid of that. And maybe we can have a thing here. So function document final persistent data is content type and persistent data upgraders persistent data current version document name. So that is now a we return a type. Return this. There we go. So now we can, instead of defining it here, we can say, well, now we also need to do init. Yeah. So we just initialize a container. So this is all we need actually. We need a list of upgraders and the container. Actually, the upgraders can also now be changed, because basically, well, I guess it doesn't really need to, because this is like very simple. Yeah, but it would be nice. We could like provide a container and use, you know, some sort of thing. If you just want to add a property, maybe that's something that we can also add upgrade in the future. So instead of doing this, you just do return and then upgrade, add field, and then the field name is like version and the default value is 1 or something like this. So then you don't even have to do this, and then it's gonna fill in the rest for you. It's just I didn't want to have this huge baggage. Well, we still need to define the frozen types, although that could also be automated actually. Or could it? No, it can't be automated. We have to keep the old types as they are. Oh man. Well, it could be automated. It could, well, not automated, but we could define each type with its own version, but that's gonna get messy as well, I think. Well, let's just do it like this for now, and we'll see if we can do it later. At least we don't have a whole bunch of crap in our actual persistent data now. Okay. Nice. Yeah, so this is all the only thing we need in our actual persistent data to get this to work. Then the generic document upgrade function will handle everything for us. So great. We still have this issue. Okay, I'm not gonna worry about that for now. So basically go through all the manual upgraders. Well, first we find a way to create the first document here. We're basically loading in the current version, and then we're going through each upgrader from that version up to the current version. And then once we are at the current version, we will basically, yeah, turn that frozen type into a real persistent data type. Okay, so let's section this off a little bit. So this will be something. I think if we take this. Now what are we doing here? We are we're basically reading in the old version. I'm just gonna say void for now. Which is gonna be a pointer. So V is the version, and it's actually const time known. And then we got previous. Oh yeah, we need allocator. We create it. We parse it with JSON. Oh, we need the file contents as well. And then, yeah, we just return the pointer. And what is the pointer? The pointer is going to be persistent data, upgraders, version, dot, document, previous. And this is what we're gonna break with. So we don't really need this, then we can just say directly here, we can say read old version. I wonder if you can define a range. No. I just want to keep this a little bit shorter so that it doesn't look. Okay. Yes. Okay, I'll just add this. Just to get rid of compiler error. I don't think that's an actual error because it asserts it. So what I was thinking is maybe it goes in here in some way, but I don't think it is going in there. Perhaps. Let's see. Wait, duplicate switch value. Excuse me. Okay. Try. Duplicate switch value. So what if like, is it can you do this? Is this why it's duplicate? I don't really understand. Do we have to have a special case if it's 0? If okay, let's do this. If end version is first document version. Well, actually, if it yeah. So if it's the same, we only have one thing to test, so we're gonna have to do all this, except I want to break this out into its own function, which is gonna be like update intermediate or upgrade. And this is gonna return another document version, and we are going to need current, which is an opaque. Actually, this should be like a pointer to a pointer of an opaque, because we want to change the actual thing of that. We also need what? The allocator. The version. Current. Upgrade, next allocator create, upgrader, next upgrader, upgrade, allocator preview, allocator subpreview, current. Okay, so we don't need anything else. And here we just return this. Well, we don't really need to return it. Okay, so let's go back here now. Basically can do upgrade intermediate. Version is V. And then we break with that. Alright. Oh, it's still complaining. Oh, but what if we return here? Okay, so that seems to work. Right, so we're upgrading intermediate, and then at the end we do this part, which is like upgrade final. And what do we need? We need current. And we don't modify current, so it doesn't need to be mutable. So we use current, then we use allocator as well. And that's it, yeah. Alright, so now up here we can say return upgrade final, could still probably section off some of these things. But here is like, okay, if we only have one version, then we do upgrade intermediate. And return upgrade final. Which can return an error, so we need to do try. Upgrade final, do no. Okay. I mean, we could put the switch in read all version instead. We don't we can, yeah. I think that makes more sense. So basically everything we're doing here, we do here. And now this is not comp time known. Oh, right. Now this is an issue. What would the return type be? We don't really have a return type here. I mean, it doesn't really matter. It's gonna be like any opaque. Actually, it's just gonna be like any opaque here. Any old opaque. Oh man, and this one. I'm just trying to shrink this thing a little bit here. Okay. Now, if the end version is equal to that, then we do upgrade immediately. So all of this, I think we're gonna put into now we'll do that's actually the same session. I was just accessing that so it's online at least. Okay, so what do we want to do here? So, I mean, this is enough. This works, but I was just thinking to make it more, maybe like have one step here, which is like upgrade intermediates, intermediate, and then we have an S there for multiple current, and the version is from version. So we upgrade the intermediates, and then we do an up at the end. We just do upgrade final because that's gonna be the same for both cases here, right? But then we define this function. I think we need to put all this in there except for a couple of things. So intermediate, upgrade final. Let's do upgrade intermediates. Okay, and then we don't do upgrade final, but we do return. And here, if we reach the current version, we just return. So that should be the same thing. Now we need allocator. We need from version. What else do we need? Current. We need to calculate the end version again, except we can say current version -1 equals first version. Then, okay, does it go in here now? That's the question. This should be the same for everything, so we could put this in a like we could put it there instead. Yeah, and now we don't need any of this. Okay, so basically, now we can see it a lot more clearer here. To upgrade a document, first we double check the version numbers. Like from version should be less than current version, because otherwise you're not really upgrading anything. Or the current version is wrong. And we also check that the first current document version that you can have, which is 0, is less than current version, which is just sanity check here. And then we could a more maybe sane way of saying this would be that from version should be less than or more than or equal, or first, yeah, it should be more than or equal to first version. So it's less than current version and more than or equal to first document version. Yeah. Right. So then we read the old version, and then we upgrade all the intermediates. So we upgrade each stage, each version is upgraded along the way up. And then we do a final upgrade from the kind of frozen struct of the final version into the real final persistent data type. Okay. Yeah. And let's see, handle upgrade document. So this one, yeah, it should work. Basically, yeah, we read in the header. We're looking for the version. If we don't find the version number, we assume it's like the oldest version, the first document version. So we try to upgrade from that. If there's another JSON error, we report it. Then we check here. If it has a version, then we check the version. If it's less than the current version, if it is, then we upgrade it. Otherwise, we just return null here. So if we upgrade it, that means we are getting an actual persistent data out of it. But if we return null, that means that, okay, we didn't need to upgrade it, so we can just read it in normally here. And we call this over here, so we need to say if we get a thing out of here, we actually get the persistent data out. And we can just use that. So I think I wanna basically copy this part into its own function. So parse file and handle upgrades, which will give us a pointer to a persistent data. And let's create this first, and we'll error defer allocator free. No. Yeah, we need allocator. Destroy persistent data. Okay. Now this is the value. So persistent data is equal to persistent data value, and I'll return persistent data. So if we need to upgrade, or if we had to upgrade, we get the actual value in here. We just populate the thing. Yeah, we create the pointer up here. If anything goes wrong, we destroy it. If we get the data, actually, if anything goes wrong, this needs to be a do this. Okay, so if we get the data from the upgrader, we just populate it and return that. Otherwise, we parse it in like normal and populate it by cloning and then deinitializing the arena from the parser, and then we return the. I guess we could have it else here to make it more. Yeah, either we populate it with the upgrader or we populate it with this. Okay. All right. so now we can remove all this and we get persistent data. Well, actually we can just do parse file and stuff upgrades try. There we go. Oh, we need file contents, of course. Also, this doesn't need to be a pointer anymore. Yeah, let's just remove that. So we do need file contents. What else do we need? I mean, I guess we could move this into the parse file itself function. Okay, now we're at this point. We're seeing a lot of errors here. We don't have upgraders on texture. Animation does not have document final. Document final, we can say upgrade document final persistent data instead. And same thing here. Actually, we could also just do that. I guess we can move it down here since this is the only thing that needs it. Okay. Right, so now we need upgrade containers and upgraders for every document. But that's all we need actually on the document. So let's go, if we go back to, which one did we do first? Time map? Right, so we don't need you, but we do need upgrade container. Okay, but that's it. Now texture doesn't have upgraders, so we'll texture documents, texture persistent data. Yeah. Going through a few iterations to get here, but okay, what else? Oops, what happened? Wait, is that all? No, you need this. Or maybe it's not going in there for. Well, it should be. Oh, because the current version is not set, I think. Maybe. It is the first. This should actually be +1. Okay, let's do a test. Let's go entity type. So basically, we're saying that, okay, you don't need an upgrade if you have the first document version. However, everyone does because we need to add the version here. So let's say here we have upgrade document. This is like the old stuff. But now we bump this. So now you see we don't have any errors. We bump this by 1. Now we should get errors. No. If we go to document generic, I mean, if we try to run it, we should get errors. Should get compiler errors. I hope. Showing up there. Unable to load file not found. What? Oh, texture upgrades. Oh, okay. So texture. Same thing here. So let's actually do this for now. Maybe that was why. Let's do this, I guess. Okay, here we go. Now we get a whole bunch of stuff. Oh man, okay. What's happening here? Oh, overflow. We're just gonna have to assume that current version is... Or we can just say upgraders length -1. What if it's empty though? Then we don't really have a thing. But it shouldn't be empty. It should actually always have 1, I guess. Why? What's going on? Why can't I do this? I mean, I'm trying to make it into what it is, says here. Why can this not be a slice? I thought this was how you made slices. But I've seen maybe doing things like this, but then that doesn't work because now it's a pointer to an array. But I mean, it's already const, right? Does it need to be const here? Okay, wait. What's going on? Okay, okay, now, okay. I think that's better. Let's see. Must be const unknown, but index. Yeah. So I think we do inline, perhaps. Yeah. Now, unable to resolve comp time value. So this is now not comp time. Let's do inline there as well. Right, inline. No field name history instruct. Oh, here we go. Here we go. Okay, cool. Well, this is a sign that it sort of works. So because we're missing the history field, it's complaining now. Okay. Also, I'm gonna remove this and rename you. Okay. Wait, are you... Scene presented as scene entity null found. So it needs an array list unmanaged. Persistent data scene entity null found versions 1. P is... Oh, it's the source. Okay, this is wrong. So we could just take the... Instead of that, we take T. Right. Items. Oh. Okay, I think we have some issues with our document. So let's go to scene 1. Now these, well, we basically banning pointers from here. We expect no pointers in any of these. That should solve that. Hopefully. Right. No member named items. So that to me says there's something wrong with the automatic like array stuff. No member named items. We're trying to upgrade a struct. Oh, okay. I see what's wrong now. So because we changed this to T, now... Okay, this actually needs to be type. This needs to be the source type because we're trying to convert. The source type has a slice, but the resulting type is a struct. So we have to check for the source here. But we cannot do the child. We have to do. We can't really use this. We have to do like type or type info of t, which we know now is a pointer. So this, or it's not a. No, it's an array list. So it's a struct. With field items. Actually, field type T. The field is what? The field is, I mean, it's items. Yeah, it's not items. And then we want, so that's the slice, and then we can take the element of that to get the element. There we go. Okay, maybe that worked. We'll see. It's gonna be interesting to see what this code will actually do when it runs. Expected type, yeah. Okay, so, well, this one, okay, let's fix the history stuff first. I think this is, so we can't just automatically do the upgrade. I think what we do is no, it's not the same as time map. Maybe we add a history here, but it's like annullable. Or can we add maybe an opaque? I think we have to have like a special upgrade for this. Let's go to our well, they should. We have to define the we have to define it on the document. But then when we read it, it's gonna be like, I don't want to have to define it because it's so annoying. Man, how do we do this? Should we just, you know, if there's a new thing, should we just like initialize it maybe? So why are we calling this function here? This should not be called for time maps, I don't think. Oh, you know what? Oh yeah, we're doing it in a final step. That's right, the final upgrade final. Here we're calling upgrade. So here we're calling like the, but then we could define. Okay, we get. Let's go timeout, persistent data. So we could say we have a struct with a function which is like upgrade final, I guess. Add history. I don't know. Upgrade, add history, whatever. It doesn't matter what it's called. So the first one is an allocator, I think. Yeah, and then we have from. The from is gonna be document 1. So this is import versions 1. Document 1. And then the resulting type will be oh no. Well, actually, yeah, it's gonna be persistent. It's gonna be this. No, it's not this. It's what's this called? Time update. Yeah, because now the sort of pseudo dependency action system will see that, okay, I'm trying to like upgrade. When we do this, we call this function with, this is the resulting type that we want, and this is actually document 1 that we send in. So this will now look into the containers and try to find a function that matches that. And if we supply this function, it should go in and match this function with that. So now we can say, okay, now we can say yeah, we just do the final. So this is like the final thing. So we just do what is happening here? Oh. Right. So we say version is current version. The where's the ID is just gonna be from ID time map. Now this one we should use upgrade value. The result is I mean, it's an array list unmanaged, but it's it's a time map. Yeah, the result is a time map. We have allocator, source is from time map, container is container. We should actually pass the container into these functions. Actually, we should have a we should pass the container as like the last thing. Container is a upgrade container, and then history. History is just gonna be like, yeah, it's just gonna be like in it here. Okay, we don't care about history right now. Okay, so that's great. Now we need to add, like, change the sort of interface of these upgrade functions. So, for example, this one needs to take container. but it's not used, so we don't care. But we need to pass in container here, which is that's just self. Oh, we still get this error. Okay. Why though? We shouldn't call upgrade object on it, because we should have it here. Did we forget to pass something somewhere? And we're getting this error in another document because it doesn't have the upgraders. Well, yeah, the texture document has no upgraders, so that's why this comes up. I guess technically we could just check, do we have any upgraders, and if we don't, then we don't care about it, but we should have upgraders for it. What is this now? Property, inner parse, JSON parse, expected one arguments found 2. Oh, right. I thought we cleared all that up. Expect this from that. Oh. Oh yeah, and also this is a pointer. We should get rid of that. So we could just use upgrade here, which means we need container here as well. Yeah, we just use upgrade. I mean, this is basically, we could just use upgrade. The only thing that we're doing is we're adding this. Yeah, we should just use upgrade. So let's get upgrade value. Oh. Right, so we need the result type, allocator, source, container. So allocator container is upgrade container. What is the resulting type? The resulting type is document next. I mean, it's basically this. Oh. Okay, let's just call this upgrade or whatever. There we go. So we'll change that. We have to pass in container now. And time map upgrader. This needs to be upgrader. Okay. Animation. No, upgrade. type. Oh, here we go. So same thing here actually. Yeah, we just do upgrade value. The resulting type is gonna be document field type. Next. Animations. And then allocator. Source is previous animations. Okay. We still get this error here. Expected union error set enum type. Where's this? Fields. Oh. It's breaking apart. Okay, let's see if maybe we can fix this shit to make it work. So it says here, expected type, array list, unmanaged, document scene, persistent data, scene entity, found, and this is, so this is, scene entity is like the target, it's like the final version that we want. But here is the previous, wait, this is the same. Oh, it's const. Okay. So it needs to be mutable. Wait, which one is it? Is it this one? This? Yeah, it's just like this needs to be a var. Okay. Strings and no memory items. I'm not trying to access string Z. Oh. Oh, I see, I see. But why does it go in there if it's a string Z? It shouldn't go in here because we should match that from the container. Does that mean the container doesn't really catch these cases in the compiler? Like it shouldn't get here if the target is a string Z, because we have a it should return the result from here and never get here in that case. I think we need to do some comp time shenanigans in that case. I think what we need to do, we need to return a function instead. We need to, yeah, I think we maybe can. Well, let's try it at least. Get upgrader. Function from, well, it's an allocator. Let's allocator, and then from is type of from, and then it returns 2. Okay, everything here is comp time. And here we just return the function. Okay. We don't need the allocator. Yeah. Redundant. Okay, sure. Still not exactly sure, like the comp time stuff, like where the boundaries are and stuff, like what happens, like when you mix comp time with runtime, what's exactly happening there. But I think now if we say we get a function from get upgrader to t from source, maybe it's better if this is just a comp time from a type instead. I don't know. So then everything is basically comp time here. Container should also be like comp time actually, but maybe it is. I don't know. We get the upgrader. This should be like a comp time known thing. If we don't, so if we get one, let's do it. Let's try a comp time here. We get the function here, upgrader. We return with the upgrader here. Allocator, source, and actually it's going to be container as well, right? Yeah. Source is not comp time. Oh, it's type of source. That's okay. Allocator. Okay, let's see. Allocator. So yeah. Wait. What if we do this? Will that work? Okay, I think that worked. So now it's like comp time known that you don't, that we actually find. It's comp time known that we find some like an dependency action here. Okay, cool. Otherwise we're using like these things. All right. Right. So what the hell is going on here? I feel like we are maybe getting somewhere. Let's see. It's gonna be fun to catch all the runtime errors that's gonna creep up on this. I'm gonna get some more coffee here, baby. Good. Let's see. Okay, so what's happening here? Access of union field struct while field pointers active. Okay. Why would it go in here? Let's double check our versions. don't think we have it. Okay, so we don't have pointers. Okay. Right. So we do have pointers in the resulting final type. We don't have pointers in our frozen types. So this means that this has to regard the resulting end type, which is correct. So it means we found an object in our frozen type, but our resulting type needs to be a pointer. So if it's a pointer, which it could be in that case, we will do now switch on type info t. If it's a struct, we get the struct out here, and we do the same thing we're doing here. Like this, okay? Except we will say s.fields. Okay? Yeah. So, but if it's a pointer, then we want to actually, if it's a struct, we do this inner part. There we go. I'm gonna do else unreachable here. Okay, if it's a pointer, we're gonna return upgrade object. Well, actually, we're gonna create a pointer. So this is gonna be the result pointer. We need to do create t. I guess we can do try. Actually, we can't do try. We need to also add like error handling support here. But let's see. So we get a resulting pointer, and we return the resulting pointer instead. But now we need to also populate it with upgrade object, and we basically take the child type of the pointer. This has to be a child type, yeah, or a main pointer, yeah. So we take that, we still use the same object and the same container. Okay. All right, what now? Okay, that solved itself almost. Expected type, scene entity found, wait, expected pointer, why would it expect a pointer? Oh, because oh yeah, we need to create a child, that's right. That is correct. Okay. And that's it. There. We still have to implement all the different stuff. Oh, we still have these issues. I'm not sure if this is actually an issue anymore. Yes, it is. Okay. Expected structure unit and inline found array or slice of scene version 1, document 1. So where is that called from? I mean, it's gonna be called from the upgrade, yeah. So if we try to run, we should get the diagnostics. Yeah, here, for example, call from here, upgrade 83. So, right, the field type of T, so T needs to be a struct, right? In this case, I'm assuming it's an array list. Right? But then it says expected struct unit error set to unit enum type found. Slice of this. Oh, I see. Because when we're okay, I see. I know what the issue is. Basically, when we the upgrader always assumes we want to upgrade slices to array lists. However, in our upgrader for something, time maps maybe? No. Well, actually, yeah, it's the time map persistent data. So it's the upgrade here. So this one, this tries to upgrade. No, it's not this one. It's the scene maybe, the scene upgrader. Here. Yeah, this upgrades from document previous to document next. However, the issue is that entities is actually, when we do this upgrade, we actually want to use a different upgrade for the slices. We don't want to upgrade them to array lists, actually. So we should use, this is like the intermediate upgrade thing. So what we could do is make this generic for everything. So we can make an immediate container. Let's go here. It's getting a bit convoluted maybe. Intermediate container. Intermediate upgrade container. So this would be upgrade slice, which takes from some sort of slice. How would we match this then, though? You know what? We could do this. We could have a function that is like, has special function that's like match upgrader, or just match. And it's gonna take from to, usually it's, I think it's the other way around. Whatever. And so it takes the from and to types, and then returns a nullable comtime, well, function allocator, well, allocator from container to. All right. So basically, if we define this function on a container, we use this function to find the matching container, the matching function. So basically, we make a more advanced dependency action system now. So now we can actually match on generics, I think. So we have to upgrade. We have to, let's see. there's probably already, you know, a very nice and robust like dependency action system out there, but it's fun to build it yourself as well. And it's sort of specialized to this feature as well. It would be cool to actually implement a real dependency action system. But this is true from, let's see, we loop through each, so I think we want to do this for like a default matcher. So we're gonna have a function called default match. Let's actually, maybe we should just have like upgrader function. Put that over there for now. Upgrader function. No, come on. Upgrade function. Return say type. Return that. This is gonna be contime from. Let's say type. Contime to type. There we go. That's the upgrader function. And then this returns upgrader function from and to. Actually, this would be like, what was the result type here? Right, so we actually need to pass in to there. All right, from to, and then we also need the like upgrade container. Which is a type also. Okay, that's the default match. Now down here we just do, here we say return, I guess comp time. I guess this entire thing is like a comp time. We can wrap it in comp time. We don't need. And then return default match from to upgrader. Oops. And I guess if we get it, we return it. Okay. Okay. Because now that we've moved that out, we can we also need the container here. right? Because if we don't match, let's say we have something that tries to match upgrade slice. If we don't, if we do, then we return that. If we don't, we end up here and we return default match from to upgrade container. Okay. Now we also need to call this function. Actually, let's try and make this work first. So, how would we do this? Well, we just need to look at the. We just need to dissect the from type. Now, I think this is like, this is gonna be like a special function. We could provide. Could we do this? Upgrade slice, make upgrade slice function. Time from element. So just element. I guess from element. And we'll return a function. I guess we'll return a, yeah, we'll return a function. It takes an allocator, takes a slice with a from element and a container, and returns the result, which would be, I guess we need a result. Slice of 2 element. Right, and then we just return a struct that has a function called upgrade slice. With allocator from, this is the from element, and the result is a slice of 2 elements. And we will allocate two elements from length. We will return that, but we also go through each from and 2 LMs let's just do from info upgrade value on that. Container. Okay. Okay, hopefully this is something, it's like it makes a function. Yeah, it makes it the reason why we do it like this is because we want the function in this format. We don't want a function that takes 2 comp time before. We need a function in this format. And so now, well, actually also we need to do upgrade slice like this. So that will return the function that we just defined, basically. It's sort of like a lambda almost. But now, let's see. So we want to match upgrade slice. And in what cases do we want to match upgrade slice? Basically any. Every case. Every slice is gonna match. So we will do switch on type info from. If from is a slice, so if it's a pointer, all pointers are gonna be a slice. And so in this case, because that's how we define our documents, we don't have pointers to structs or whatever. Now in this case, we return make whatever function. The from element is p.child. The to element should be to.child basically. So it's like type, so it's like, well, we do have lm here too. Okay. If we don't find, if it's anything else, we can do this. So we've just made a more advanced sort of dependency action matching on the types here. So we can actually support matching on generics, but it's a bit annoying. You have to do it like this. You can't just have a magical thing. We might do something like that in the future where it automatically, it like you make a type called something like any type, and it's just an empty struct or something like this. And then you can use this to match, like let's say someone wants to makes an upgrader function that takes like allocator, and then from is like this, and then to is gonna be this. Okay, then that will match on any. So you could do something like that as well, I think. Well, you could try at least, see if it works. Hopefully any type will be like a unique representation of the type. Otherwise you could do like a string match on the type name or something like that. But anyway, so alright. So now what we want to do, we want to check on each container if it contains a match function, then we want to use that. If it doesn't contain a match function, then we just use the default match. So for each, and that's going to be like for each container. so here. So we do a default match, but we want to also check if has declaration upgrader and the name is match, then we want to check, we want to call that if, actually, you know what? Do we want to enable, like, do we want default match to be like, you want to default that otherwise, or do you want to just, like, because then we don't really need to do an else default match here. We like always use the default match if nothing comes out from match function. Or do we want match to be able to say, okay, if we didn't match this, it's not gonna match anything? Well, let's just keep it like this one. If so we do else, we do a default match. If upgrader dot match from to upgrade. Well, we don't really need a container because we already have the container. Well, actually, no, this is just one container. Yeah. So we don't really need to pass the container in. We already know we're not really using this anyway. We are using it for default match, I guess. Except this is just self. Whoops. Wait, what the hell is select? Select. Oh, okay. This is this. Yeah. So here we don't need to call that. If we get an upgrader from match, we return that. Otherwise, we try to find it with a default match. There we go. Okay. Wow, no errors. Interesting. Also, I think we can remove this function here. Alright. Well, we do have errors in other places, but very interesting. We didn't get any like compiler errors or anything from all of this. But okay, so now we have like intermediate upgrade container. But I mean, I guess we don't really call this now because we don't really use it. But if we go to our generic document and we do here, we have an upgrader. When we call, we don't really use the upgrader function though. So here we're not really doing that. Intermediates, here we are. So the question is, no, with intermediates it's always going to be the same. We don't need any special kind of intermediate upgraders that is specific to a document. What we do is we will upgrade, like in this upgrade intermediate function, instead of passing the upgrade container from persistent data, we are going to pass in upgrade.intermediate upgrade container. So that will change how which upgrade functions are available. So that will actually add now the slices. So the slices will upgrade into wait, intermediate upgrade container, yeah. But we need to like make our own, like that's gonna be a container itself, probably. Yeah, so this is gonna be actually container. Let's just do container. Let's do init without standard. return container and upgraders is just gonna be upgraders. There we go. Alright, so now this guy, intermediate, we are going to say this is a... So that's the intermediate upgrade container. Let's do this. And we'll say container. Should we just do... Intermediate is going to be container init without standard, and then we'll do intermediate. All right. Now here we're gonna say this is container dot intermediate. All right, let's go back to here. And do we have anything here? Okay, here we go. Unable to unwrap null. Interesting. So it is called from upgrade a match. I guess we could do or else. We do a compiler log. Function return type is null. Function name. That's interesting. Match. What? Oh. Okay. If okay, so if the declaration name, okay, so if it's equal, no, memory equal, if it's, come on, where am I? If name is equal to match, we continue. Do we get function? No. Okay, so now we don't get this error. Okay, cool. Okay, so we do get this error. Expected type nullable function allocator slice container slice found function allocator slice upgrade slice. Okay, so I think then do we have versions that that they are not const? Yes. So they should this should be const. We shouldn't have any that are not const. Okay, it still complains here. Am I not making the correct? Okay, so it might be that we have to add const. Basically, all of these needs to be const. So I think we can just do this. Okay, expected type. Right, so now we need to go through all the versions and make sure everything is a const. Every slice should be a const. Basically, we're gonna search for this and not this. Okay. Expected type, novel allocator, star align 16 U8. What? Is that for the final? Okay, let's check the call stack to that. Oops. Expected type. Yeah. Yes. You can see the generic thing works. It's as of here. So it's upgrades from 0 to 1 in scene. Scene upgrades here. Okay. So it's like, why does it think, what does it get this from? Align 6, like a pointer align 16 U8. Where does that come from? Good. Yeah, we don't have any pointers. So I wonder which it is. If we go like upgrade value, we should be here. Yeah, this is the upgrader that we call. Then we go to upgrade value. It's gonna upgrade a slice, which is this slice. Then we upgrade the object, which is this object. Now we're upgrading some sort of union, so it has to be the type. Okay. And then we're going in upgrading an object, so it's one of the types. And then another object, which could be the properties. And then another object, another object. Yeah, it has to be the properties, I think. So it goes in here, down you have fields, ID property. It goes into object again. And then we probably, no, we don't have an object. Well, it's gonna be the string or, yeah, because these are UUIDs, so it's gonna be this one, but that's just a normal string. So yeah, it's something weird happening with the types that gets like generated, I think, from the upgrader container, that like weirdly converts it to a pointer. And then here, no, it's when it's get called. This child expected. Is it the result type of this call? So it expects that, so it's already like the from and to already has this weird type, which I don't understand how it gets it. We're just passing. So how are we constructing this type then? Type of source. If it's a slice, shouldn't it just be a slice in that case? Should we then just convert it, like we can say maybe pointer cast in that case? Well, it's not really pointer cast, it's more like we want to make a new type. It's like it's not preserving the type fully here. Because I think there's going to be a difference. Like if you have a store, a slice with a store in it, doesn't that mean it's like unknown length or something? What was it more like a line 16 for some reason? Like we're so is this... No, it's the intermediate step, I think. Yeah. Yeah, so okay, so the result type is also that. Why? Why? Is it the align cost or whatever? That's the weird thing. And if we don't have it, it's gonna complain. What if we do this? Okay, I think I need to Google AnyOpaque a little bit. AnyOpaque into pointer. So you can't do that? Is it because it doesn't know? I mean, it should. Isn't a slice a struct, basically? So why can't it keep the information? Like, if we assume that it's a slice, why can't it just cast it directly? I don't understand. Maybe we can do a bit cost. I guess you can't dereference an opaque. Wait, cannot bit cost to this? Wait, what's happening here? This isn't a pointer. Wait, it is a pointer. Yeah, okay. It is a pointer. So we can't bitcast into a pointer. What if we... Can you say... Musik, Europäisk, Like, the thing is, I don't understand. Now, this shouldn't do anything because to the type, right? I don't understand why. I suppose we're sending in document previous. This is already a defined type. It should already have the defined, like the type should already be defined properly. Where are we changing the type? Here we're just grabbing out the elements. It's already wrong coming in here, I think. And here. So it's like it's already wrong coming in here. So it's like if I upgrade object, and the resulting type is a pointer, but it shouldn't be. It shouldn't be going in here, I don't think. $150, yeah. Optional. Wait, this is not intermediate, right? Wait, why do we get hash? No. Oh, I see, okay. This is scene, yeah, scene versions. Yeah, it's this one, array hash map. Wow. We should have, okay, so this, we should support this as well then natively in the upgrade system. Let's do that, actually. Let's, maybe that's the issue, actually. So, yes, if we encounter this type, then we should have a, should we have a standard? We should have a standard for it as well. So the standard upgrade for that is basically gonna be, we're upgrading this into string Z array hash map. what is it called? Array hash map? No. Yeah, it's called strings that array hash map. So this is what we want to use in the final step, but in the intermediate step we want to instead turn it into another hash map. But as it is with this one, we actually need to create another function like this for array hash maps. Upgrade JSON array, well actually just array hash map from element to element. And this now is JSON array hash map. And this is that. I'd realize also if the standard library changes and makes a breaking change, well, that's gonna be like a sig pro. That's gonna be okay. Yeah, that's gonna be a different thing. We can handle that at that case. We don't. That's not gonna be a problem. Okay, but anyway, we can always change this anyway. So we got the standard array hash map. Yeah. So this would be upgrade array hash map. And we're gonna get a standard JSON array hash map. Array hash map. Oops. Oh. Array hash map. 2 Okay. Except over here we want to say we want to create, oh yeah, also yeah, we also want to I guess defer free from elements, or from, yeah, that's right, we're gonna free it up as well. Okay, so 2 elements. So what are we doing here? So we need to create a standard JSON array hash map from 2 elements. So let's just start with we have to define map. Do we have empty on that? Yes, we do. So we start with empty, except we don't, because we want to init with capacity, right? No, there's no init capacity. It should be. Init. I guess we can ensure the capacity. Okay, let's do empty first, and then we do map ensure capacity. New capacity is going to be from map size, I believe. No? Count? Yeah, count. And sketch unreachable. Okay. So now we make sure we have the capacity. Then we're gonna get from map count well, let's just do map values. No, wait. Yeah. Values. And then we also do the integer. So here's the value. Here's from element. And then 2 elements. Actually, we need to do like put map, put assume capacity, key, and the value is going to be upgrade value. 2 element allocator from element container. Yeah. K is from the keys. Okay, and then we say here if we have a no, it's not a pointer. It's if we have. I mean, it's going to be a struct. So we need to match. Array hash map. How do we do that? Let's check if it has a map field, which the map should be this. And how do we check if it's that? It should have like, I guess, entries. If we have map and if map has, I guess, entries, then let's just assume that it's a we want to get the child type. But wait, how do we... So... No, wait, so I think map actually just have k. Let's just return map.k, I think. Or is it kvk? K. Yeah, it's kvk. KV key. No. K. Where's the type, I guess? So it doesn't. Yeah, so we can say K type of kv.k or something like that. Yeah. Here we are. So kv, and then we get the field type of key. Actually, there. Alright, that is the thing. And then if we don't find it, we just return no. Alright. This would be get array hash map element from or else default match. Okay. Okay, now we get in here. Expected type hash map. Found type. Function from, well, allocator hash map versions 1 property object 0 upgrader into array hash map versions 1. Okay, that looks good, I think. Found type. Oh yeah. Okay, yeah. So if we get this, we get the child type or the element type from element. And now we make this. What about two element? Oh man. I guess we need that as well. Let's do so from element is equal to this part, oops, or else break couldn't we? I wish there was a way now to like null defer or something. Or else defer. Like we defer break. No, that doesn't work. Or does it? Maybe no, it doesn't. We don't want to do that. Right, and then break with that. Actually, we could probably just add return stuff. And then we don't really need this break thing. We could just say return. Actually, you know what? Let's just do else, do nothing, and if we don't find anything, we do a return. Oops. Like this. And then here we can just say break. There we go. Alright. Else break. Return. If no, this is always going up. Yeah, so this doesn't make sense. And we have to run that now. There we go. All right. Expected. Yeah. Break outside loop. What? But it's in a switch. What? Do we have to do this? Or I don't understand. I thought you could just break out of a switch. Okay, fine. Expected type function memory allocator from hash map version 0 property of 0 container JSON2 array hash map property 1 found function memory allocator hash map of slice into array hash map to a slice. What? What? Wait. From element to element, from element to element. From element to element. Field type key. Wait, key. Wait. No, it's not key. It's value, right? We need the value. Yeah, what am I doing? Value. There we go. Alright. Okay. Expected type, array hash map unmanaged. Wait, where am I now? Oh, this is, I think this is variable. There we go. Wow, okay, that's it. Okay, progress. Now it doesn't feel as bad to do this kind of thing because it's super generic and yeah, it's gonna sort of work itself out. The bad thing about this implementation is like if you've not been here for a while and you go back to it, it's gonna feel like a whole thing to just if you need to fix something, it's gonna be, you need to get a lot of stuff in your head just to try and fix the issue, and it's gonna feel really, really bad. But hey, at least sometimes it should work. Hopefully we'll catch most of the cases that's gonna be used, and we have this automatic sort of upgrader for our stuff. Indexing into empty tuples not allowed. Function with non oh yeah. Expected structure. Oh, this one again. Wait, is this even an issue now? Hopefully not now. Oh, I still see the star line 16 there. That is a pain in the ass. Okay. Let's see what we get here. Indexing temporary, sure. What am I seeing here? Expected, okay. Where is this coming from? Element, field type, upgrade object. Upgrade object on which final? Okay. Something else is happening. Cool. Add history. Alright, so we see that it actually goes in here. So there's something weird with this. So add history. Okay, let's check this add history. So it's in time map persistent data add history. It's here. Right, so this container, this is part of the final thing. So we should assume that the tile map is now the previous document, or the like the frozen version, and the result is gonna be an actual time map. Yeah. Okay. Value object value list value object and then there's some object in the time map, so it doesn't have anything to do with history. It's just because we're in the add history function. So there's something in the time map that's not supposed to be, that's not really working correctly. The field type, so this is upgrade object, so 196. Here. So we're checking. Wait, call from here, standard meta. Field type T items. Oh, it's then it's in here. There's an upgrade. Okay, so it goes in here. And this is the part where it craps up. So we're checking the result type dot items. And it complains that it's expecting a okay. Now I wonder which field it's looking at. It's looking at dot items. For the result type of what? So object new list. The list is gonna be this. So it does go in here. Right, and then object, yes. And then another object, which is probably array list, right? Oh, is it the vectors? Maybe. Wait. Is a vector do I need, is this the issue? Expect to instruct unit. Okay. Found this? Okay, it's not the vector. It's this. Oh, it's that. I see. This is like one of the only places where we don't actually have a string Z. So, okay, so I should follow my own rule to actually upgrade this into a string Z then. Okay. Yeah. That's fine. We can do that. Right? And you know, now we don't have to worry about this crap. Let's remove that. It's not used anywhere else, I hope. Whoa. Okay, well it's used here, but this is gonna be name. No, this is gonna be string Z. Well, it's gonna be init. To do this crap. We don't need to have a function called setName. We can remove this. We don't need this. We don't need you. We don't need this. We can just return that. Very nice. Clone. We just do self clone down here. We do self-name initialize instead. Oh, self.name clone. Add layer name. Nice. Okay, and yeah, now we have this thing. So this should be name.buffer. And name dot set. What is data? Oh. Buffer. Yeah. Sure. Okay, let's just do format then. Set format. Okay. What the hell is going on? Found star array. What the why? Field type. So upgrade 172 again. Which is from what? Upgrade final on which document? We don't know. Well, okay. Let's actually just try and implement the rest of the things, and we'll see what remains after that. So yeah, now we have this one, which is a special case because we want to add. We don't want to deal with the history. Okay. Let's go to texture. So we do need to do this. And do we have an upgrade? No. This doesn't exist. So let's make upgrades. Versions 0. Oh, texture file path is bad as well. Alright, but let's do that. So that's very simple. And then actually now, no, wait. We need you and then one. Actually add version to it. There we go. So that's our versions. But here, this also needs to change it as string Z, I think. Yeah, we force everything to have string Z now. So maybe empty. Do we have that? We do. Except it's like undefined. Right, but it should always be there if it is. So texture file path, initialize, clone. All right. Well, view. So, okay, this one has some issues. So texture file path here. If the length is 0, we return. Okay, if texture prepares. Yes, okay. So that's everything in there. What the hell is this now? Set. Okay, fine. If it's more than 0, we free it up. So we should probably just do... Oh, wait. No, we'll just... deinitialize it, I guess. Or actually, no. We just set it. Set to this. Don't need to do anything else. There we go. We don't need it. Okay. Right. Yes. Okay. Cool. And now I need you to change somewhere here. We don't need that. Okay. There we go. Now the question is, when we create this document, it's gonna be set to undefined, which no, it shouldn't be undefined. Texture persistent data. It shouldn't be set to undefined. It should just be set. Well, it's set to empty. It should be set to just initialize with an empty string, I guess. Okay. Right, it's acting up here, so textures, document. So we need 0 to 1 here. Now let's grab, whoops. Let's grab, I don't know, the scene upgrader. Sure, why not? There we go. So we have version, ID, texture file path is the same, and that's it. Okay. And this is not true here. Okay. Now we get all these weird errors. Okay. And we still have some of these left. Oh yeah, we need an allocator. Oops. Okay. Still get this error here. But I think it has dropped a little bit. Okay, so we still have these two things. Array hash map index header. Interesting. from what? Final? In which one is the question? See, we don't, it's so generic now, we don't even see which document is actually, maybe like doing this, context document, open document, content, so it's from scene map. Find starting scene. 45. So it's a scene document. Okay, so it's the final upgrade in the scene document. What could be? We have an array list of scene. So probably like deep in like scene entities stuff here. Let's just check if we have any illegal types here. Custom probably. Maybe we should have like a compile a like, yeah, this is the property that where this error is happening. But I don't, maybe we can't really catch these, but it would be cool if we could. We get a little bit of trace here, but it's like we don't really know which one it is. But I'm just gonna look through here to see if we have anything weird happening. We do have an array hash map here, so that might be it. String Z array hash map. Oh wait, yeah, we never implemented that. That's right, we never implemented that. But there's an issue here that I'm realizing. How do we know? Like, we have string Z array hash map. Well, I guess we could look at the context. We could look at the context maybe. Do you save the context somewhere? Managed. Here we could look at this. We could look at managed. If it's available. Here we got context, so we could look at the context. Yeah. We don't have context here. But we could look at managed and then type of field like CTX, and we get the context out. We could do that to get the context. Okay. Because the issue is that if we look at property here, now this is a string Z array hash map. However, in other places, we have a different type of hash map. We have a ID array hash map somewhere. Maybe we don't actually have it in the document itself. Really? No, we don't. Okay. So actually we could just assume that it's a string Z array hash map in that case. This is basically the only place that we have it, so okay, but then that's fine. We can just assume that it's a string Z array hash map, and we can have a default implementation for that. So if the source is an array hash map, the target is always string Z array hash map. All right. Now I think we do need a special matcher for that to see if it's an actual array hash map. Yeah, so we do need to basically copy this and this. And now this will be string Z. And there's an empty. Otherwise, it should be basically the same thing. Except the key we need to wait. Put yeah, it's just gonna be this. Oh man, expected this. Found that. Okay. We could just point a cast, I think. Maybe. We need to duplicate it anyway. It's gonna be. Okay, let's do. Duplicate. We also need to free these actually. Oh yeah, it's free. And we also need to free you. Put you in there. And then we also do defer from the initialize. Yeah, we forgot to do that, otherwise there's gonna be leaks. Same thing here. The initialize from free the key. Actually, no, we just put it into the new one. That's right. We don't have to free the key because the key is gonna be, it's gonna basically gonna be reused almost here. So that's fine. Oh, we need this to be a pointer. Oh is not great. But why do we need it to be a pointer? Is it just because it's changing things here? We don't really care. We're gonna throw it away anyway. Is there like another? From map. Clear and free. No, this still needs. We don't care about the thing. We just. Okay, let's check. What is this doing? Entries. We're freeing this, and then we're setting. This is the only way. Only reason why it needs to be mutable. Can we? Okay, but then okay. If it doesn't matter, we can just do this. We can say from mutable is equal to from. Okay, and then there's our mutable version. So now this should be good. And we'll do the same here, from mutable. Because it's just gonna get thrown away anyway, you know. There we go. I wonder if you could do const cast. Will this work? Okay, well, I don't know. It doesn't really matter. It's not really nice looking anyway, so. Okay, wait. Okay, so is that it? Let me just double check here. So the slice we're freeing from, and each value is getting upgraded, so that's fine. Here we are freeing from and moving the key, so that's fine. Well, we're not moving anything. We're just reusing the key. And here we are freeing from there. Here we're also freeing from. We are freeing up the key, previous key, and this duplicate that we have to put in here, but then that is all in self duplicated down the line here and used in the new hash map, so that's fine. Okay, let's see where we're at now. So expected something found whatever it is, this part. Okay, so we have that somewhere in our documents, file contents. No, where is this? Layers menu. Oh, what's this? Layout, time app. Oh, format. Wait, expected. Tuple or struct or right. There we go. Oh, there's no expected left. Wow. Okay. Cool. So, what are you complaining about? So, entity type. Entity type does not have the required stuff. Right. So, let's go to, I guess, animation or something, and we will grab this, put this over here. This should be exactly the same code. Let's grab upgrade. Alright, now we need to add upgraders, versions, 0. This is gonna be entity type, persistent data, and these things. Except for the version. Okay. Oh, we also have property object. Ooh. Should we just do a quick dirty import here? Where do we have it? In scene, I think. Versions 0. Property object should be public. Okay, and then we have entity type icon, which is pretty easy. All right, and that's it. No. That was pretty easy actually. Okay, so let's go entity type, persistent data. Yeah, and this is basically done now. Oh yeah, I need upgrader as well. Yeah. So upgraders 0 to 1. Let's just grab the scene upgrader. Why not? All right. Oh yeah, we need document 1 as well. It's just going to be document 0 with this is going to be the same thing. So let's import versions. Oh, import 0 dot entity type icon 0. Let's make it public. Sure. Alright, it's the same thing. Yeah, it's probably good to have it always be, because otherwise it's too easy to just copy over something and have it not be different. Or should we always copy the thing? I don't know. No, we shouldn't. These are meant to be frozen. So they are not meant to be changed at any point in time, unless we fundamentally change, like, I don't know, maybe the string representation or anything else. But they should be always like this. Okay. They basically follow the same rules as the actual persistent data, except that we don't allow it to refer to any of the sort of mutable types, so to speak. These are constant types, we could say. Alright. Okay, now we go back here. This should now exist. There we go. Whoops. But what do we have here? We have properties, name, icons. Let's start with name. Previous name. I think we can just copy that. We don't really need to do anything with that. icon is, yeah, we just copy, nothing's really changed, so we don't need to do anything. There we go. So actually, why, so we don't, oh, we probably need to copy it though. But this is a property object 0 as well. It should probably be like property object 1. Yeah. Well, the icon is literally the same type. The properties should also be the same type. So actually, also the document tag is the same. Property object 1 should be public, and we just set this to be import 0 property object 0, and then we can remove all this. There we go. And we should probably have the same for like entities and everything. Like if we go back, because then it's gonna be way easier to define this. So if we go back to, well, we need to go back to 0. And if we say that this part, we break this out into entities 0, well, it's going to be that. No. And I guess that's it for now. We don't need to do more with that. Now we can just say that this is entity 0. And document 1, I mean, it's basically gonna be import 0 entity 0. So we basically just upgrade the things that we need, which is we're adding a version, so we just do that. The rest is basically, it's the same thing. All right, and then maybe in the future we'll add a more better sort of thing where you can just say const document 1 is equal to add property or add fields. And then you have like document 0, and you want to add version and then document version. So basically you just do things like this, where you create new types, and then you basically don't need any of these. Actually, we don't actually need any of this. So, well, I guess we'll keep them because they are going to be separate versioned things. But this would be a lot easier way to do it. But this is, I guess, good start. Wait. Oh yeah, so here's where we define everything. Yeah. Okay, and then back to entity type. So version 0. This is property 0. Yes. And then version 1. We basically say, well, entity type 1. We basically say that the type icon has not changed. These are still the same, and then the properties are just the same thing. Basically, it's almost the same thing as document 0, except we just add a version, which we haven't done. So document version there. There we go. All right, now entity type upgraders. Right, so now the question is, will this work here? It seems to work because they are the same thing. So, and if we now go to upgraders for the scene, yeah, there's going to be a difference here because the scene version of entities is different than scene version 1 entities is different from scene version 2 because the time, no wait, it's not actually. This is exactly the same, so we don't even need to call upgrade value here. We can just set it to prep entities because it's the same thing. Now we don't need these. There we go. So we just need to add version there. Okay, textures, same thing there. Timeout, we haven't done yet. That's the only thing we need to actually implement a new sort of thing. Now animations is also the same thing. So we have animation 1. They should just be the same thing. So we just import version 0, animation 0. Which is somewhere, yes, I mean it's over here. Let's make this public, and that's gonna be it. We don't do the frame, I don't think, no. Well, we could, I guess, so that it's actually defined, even though it's not different here. Even though animation 1 actually refers to frame 0 and not frame 1, but it's fine. It's fine. All right. And then we actually, yeah, we can do the same thing here. We just pass that along because it's the same type. And now we don't need you, we don't need you. There we go. All right. Still feels like we're adding a little bit of baggage here, but it's nice to have the system in place. Like next time we do a break and change, we can implement an upgrader for that thing. Well, I haven't tested this out yet in runtime, see if it actually works. And I've yet to implement this one, which is the actual thing that we needed to do from the start. So let's do that. And you can see the breaking change is this. The old version had tiles in a flat array, now it's a 2D array. So we basically need to take in a flat array. We need to check what is the width and height and just create a new 2D array and map the things over to the new 2D array. So, right. So let's just return document next. All right, version is version 1. ID, so that's also like new. ID is previous ID. Time map, now we have to do stuff. So, I mean, I guess it's just gonna be like upgrade. Actually, you know what? We don't really need these upgraders. Almost. Well, like instead of doing this, what we could do, okay, now I'm changing it again, but it's fine because it's the first version here. Instead of having this upgrade thing, we just need to, but how we're gonna do like the versions, we need to add like versions in a list. We need to have a list of versions, that's what we need. But let's do time map. Persistent data. So instead of having a list of upgraders, I think what we need is we need a list of versions, which has versions and a 0 and a 1. So instead of having upgrades, we have versions, because then we can check, okay, which does the version match the array in this list. If it does, then we know that it's that version, and we can grab that version, and then we can get the next version by just incrementing the array, or like take the next index of this array. So it's essentially the same thing as upgraders. However, upgrade is not really needed, because what we can do is we can say we can just add an upgrader here. So we can just say, okay, I want an upgrader for 0 to 1 from import versions 0, or we can just say versions 0. Yeah, version 0, that's a type. From this version, to versions 1. So this will be the intermediate upgrader. So we don't need to define it in its own file like this. We can have the dependency action actually find this upgrader with the signature that we have now, and just use that. So this would be the actual upgrader, and then we also have the container as well. Upgrade container. All right. Okay, so we can do it. We can do that. We can still have, like, you know, break and change. We can still have this comment. Although I guess we could import the upgrader from. Maybe we could just use pub names using namespace or something. You know what? Let's just keep it how we have it. I mean, it's possible to do it that way. I'm not sure what's best, but I'm not gonna dilly-dally about that right now. So let's just do this upgrade. However, what we could do, we are upgrading to what? A document next. I mean, we're upgrading to document next version of this. I wonder if there's a way to, from a function standpoint, like in the function, like let's say in here, I wonder if there's a way, if you could, the return value is like the result location or whatever it's called. If you could sort of infer the result location. Is there a way to do that? I guess you would have to provide a variable comp time. But I would like to infer it. It would be cool if you could infer the thing. There's no program plan to return type inference. Okay, whatever. So, what am I doing? Yeah, so we return this or remove this. Yeah, what is the result type here? It's gonna be like field type, dot next, time map. Previous dot time map. Container. Alright, now we can't just automatically do, well, actually we could. It's just it's an intermediate. No. What we need to do is, well, we can't just do this, I guess. We have to like, well, we could actually modify the container. We could create a new container that has a special case for time map layers, I think. And this is gonna be container. Maybe I should have a special case for this. Merge or something, like add, and then that turns a new container. Here's self container, and we need comp time operator, which is a type. And yeah, this will be just return container init without standard, self upgraders plus this. Pretty sure. Now we can say add oh wait, it's actually container add upgrade layer, which returns there's gonna be like oh, we haven't done it here. Okay, so let's do podcast, time map 0, no, tile, wait. Yeah, time map 0. Oops. Let's just make these things. And you will be layer or time up layer 0. And I guess we need tile. And tile source. Yeah, now we can reuse this as well. So. Cool. I should probably have like a sanity check to see, like, okay, it does the types in here actually fit within the types instead of getting these obscure errors. We want to see, like, does it fit in the actual constraints of how we want to define our stuff. Is yeah. So now this is actually different. So this will be time. So time at 1. All right, grid should be the same. So we can just do grid 0. Tile size didn't change. Layers does change. There we go. Grid should be the same as well. Name same. Tiles are now stored as a 2-dimensional array, except the inner part didn't change, so we can just use tile 0 there. Alright. Not that bloody, I guess. Okay. But it would be nice, instead of doing this, to just say, like, okay, popconst document 1 equals, and then, like, we have some sort of, like, apply or sequence, apply or add fields, and you begin with document 0, and then you have you add a version with default value 1 or something. No, wait. Document version like this. And then the next thing you want to do is, like, so that's more like a functional approach.
next thing you would do is like have some sort of like lens into tiles to change it. So basically replace, and then we have a fields. So basically you could actually have a list and then a thing here. So we do like dot tile map, and then the next one is going to be dot layers, and then dot tiles, something like this, and then you replace this with whatever you need here. So instead of doing all this, you could do this, but that's a whole other thing. I'm not gonna do that. It's been fun doing this system here, but I want to also get done with it as well. So now we have those things defined. So now we can go here and we can actually say timer play 1. So that's layer 1. So just keep it the same name. And yeah, we have an allocator. We have from, which is going to be timer layer 0. And then we return timer player 1. And we also get the container, but we already have it, so we don't really, well, I guess if we need it, we need to like keep the same scope going. So what now? So the container here, we actually want to use the upgrade container now instead. So we're replacing our container with another container. So basically in this scope we are actually using this upgrader. So that's kind of cool that we can like switch out the scope. That's also very like dependency injection. Let's go for that. Let's see how much time I have left here. All right, I need to eat something as well. I don't think I've eaten today. Okay, but anyway, I'm gonna make sure I do that. Oh yeah, this is 0. That's why it doesn't work. This should be upgrade container. There we go. I'm feeling we get a bit woozy only drinking coffee right now, so I'm not sure why I should be hungry. Like I'm a little bit hungry, but okay. Anyway, so that's pretty cool. Okay, now next thing is we wanna do the actual upgrade. It feels like I'm procrastinating this actual algorithm that we're trying to do here. So right. We have a flat array. We want to make it a 2D array. So we need the size of the thing, which is the grid size. So we do have the grid size. This size. This is the grid size. It's always the same for every layer. So we don't really need to worry about that. We can just grab the grid size from here. Actually, we should grab it from here because that's the actual layer's grid size. It might be, you might have. In the future, okay. I'm not gonna talk about the future. Stop worrying about the future, okay? That's how we got into this mess from the start. So it was really not necessary to do all this, but probably way faster to just write a script for it. But we have a system in place. It was fun to do. Blah 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 blah. Okay. Anyway, let's get this done. Let's get this done and see if it actually works. It would be really cool if it actually works, you know. From grid size. Okay, we have the size, so we can create. Now we can create the new 2D array. So we'll do the return time at play 1, and I guess we can just copy these things for now. ID name grid shouldn't change either, so we can just do this. Now tiles will change, so this is the part we need. Tiles. Now what is tiles? Tiles is going to be just an allocation really of the results, which is tile 1. So we need this type as well. Tile 1. Is that not made public? Oh, right. Let's just make this public. Actually, know what? We can also make the grid 1. Grid 1, tile 1, there we go. So we should have tile 1 now, yes. Alright. So we're trying to make a list of lists of tile 1. The size is going to be the Y. So it's going to be... Let's actually grab out height. Wait, width and height. Oops. I'm pretty sure you can do this. This is a vector though. Is it possible to do that? Maybe, I don't know. Maybe not. Allocator. It's gonna be the same allocator. Let's just skip that. Okay, that works. So we get that. It does say unknown though. Okay, whatever. Let's do... Oh yeah, this is gonna be height. Okay, so we'll do that. Cache reachable. And now we will look through all the tiles. Get a row out. Okay. All right, now we need to oops, we need to allocate this now for width. Right, and then we can do we need an index, which is going to be width times wait actually yeah, this what does this represents Y, and then we do width, this represents X, and then we need the index, which is going to be Y, width times Y plus X. Alright. But then these are actually not like U sizes. Actually this is, yeah, so we need to do, actually what we want to do is this needs to be U size, so Let's just do vector2 usize incast. Alright, now we have, yeah, these width and height should now be usize. Oops. Okay, so now we have index, so row x should be up, so upgrade value, and the value that we need is tile 1, and the value we're getting from is from tiles I, and we have the container, which is this container here. Layer container, I guess we call it. Alright. Okay. Okay, so we're building up the thing. We grab the size, width and height. We allocate first the rows by the height, so we get height number of rows. Then we go through each row here, and we keep track of the y coordinate in the grid, and then we allocate, for each row we're allocating w amount of tiles, and then we're also going through each tile, each row with width number of times, and we keep track of x. We calculate the index we need to look into the 2D, or the flat array I mean, which is width times y plus x. So each y adds width amount of to the index, and x is just a flat add x. Okay, and then we say row of x, because row is the 2D array, so row x is going to be equal to yeah, and then we up to the new tile. Then we just upgrade the tile. We could actually, we don't really need to upgrade the tile. We can just set it to the old tile because it's the same type. So actually, we just need to do this. We need to, yeah, we just need to do that, and then we just return that. Now we also need to defer allocator free from tiles, so the old tile thing is freed up because we don't want to use it anymore. There we go. I think that should be good, and we're not using this, so okay. Do we have any errors left? Not in that part. Let's see if we actually get something here. Yes, we do. Unable to load entity type upgrades, file not found. What? Oh, upgraders. That's wrong, right? Upgraders. It should be called upgrades. Maybe it should be called upgraders. No. Where is this imported from? We don't see where. Okay. Now it's called. Now it should be there instead. Okay. Do we have any errors? I don't know. Let's save this. Okay, we do have errors now. Okay, let's see. Allocator not accessible from inner function. Okay. Interesting. So we need allocator from here, but then it doesn't allow... Okay. It doesn't allow it to be shadowed, even though it can't access it. Okay, that's an amount of pedanticness that I don't understand. But okay. Let's just call it something else. I guess we could move this struct somewhere, because it doesn't really need to be, you know, a layer upgrader. Yeah. It doesn't need to be like okay, I forgot what I was gonna say. These things can be added down here. Don't really need them here though. And now we add layer upgrader. Pretty cool actually. Does not support indexing. What? Oh, do I need to dereference it first? Oh yeah, that makes sense. Cannot assign to a constant. This shouldn't be a... Oh, it's a constant. Wait. Okay, so when we create them, it's gonna be a problem if it's doesn't allow constants here. I wonder if you can just cheat and do some sort of const cast or something, I don't know. I mean, you should be able to do this. Let's say we do this. No, because the pointer is... But then we cannot duplicate it, I guess. It feels strange. Wait, there's no error. What? Oh, I guess I can. Wait, no, but this is strange. This says it's supposed to be const, and then this is not const. How does that work? Like it should just be a pointer that gets passed. So now, I mean, after that, I can go ahead and go into something here, and I can like change this to true or something, and then it's not const anymore, right? Isn't that the point of const? So that you can't change it? Maybe it doesn't become an error until we fix the other stuff. So what the hell is this now? Okay, so it's in upgrade object. Is there something wrong with the types? Wait, expected, found this, where? Is it in here? source. No. Where is it finding that final? Oh. Deserialize. I don't see which document it is, but I'm gonna guess it's time map because that's the last part that we haven't done. So let's go to persistent data and see if there's anything in here that is bad. Is it in history? Ooh, it might be in history. No. Oh, maybe not actually. Okay, so it's not in history. Okay, good. So it's in here somewhere. No. Okay, I need to be right back. All right, let's continue. Okay. So, what the? Okay, so it's not in. I mean, it's not in here. Is it even in time app? I don't think so. We check that. How? Where? Why? How? Actually, persistent data, non-persistent data. Actually, it should be more like this. Tile set. Wait, what's this? Is this even used? I don't think so. I don't think this is actually used. This is like super old code, I think. Should we just remove this? Yeah, just okay. So let's do this again. Okay, time map. String, yeah, that's fine. Project is not part of this. This is not part of this. This is not part of this. This is fine. Everything is fine. New asset as manager, generic. Texture notice and property. No, I don't understand where this comes from. The only thing is like the string Z stuff. Is it the key? No. Does it come from here? Is the question. No, let this one. This one. Does it come from here is the question. I don't think so, because the key that we create, we're doing it sort of manually here. And its complaint is fine. It's what? It's complaining about this in a final, some kind of final thing. I wish it would show which. I wish I could catch this error. Can you catch compiler errors and show, like, can you have a try in a comp time? Okay, I'm reading here. Let's see. So someone did this. Try comp time. This version also is the compiler. Seems to me like it should work. Okay, so you do a try, and it hits compile error. So I'm pretty sure this is not possible. I don't think. Comp time. Let's catch compiler error. Could we catch compiler error? Because I want to catch it so I can see, so that I can get more information about what's happening. I guess what we could do is try and add some way of like validating the type and then say, and then report an error instead of just crashing here. Or crashing, I mean, we are sort of crashing in the compiler comp time. So it's like, what is a valid value? So you could have here, you could have like validate type, and it's not from type, it's going to be Wait, is it from? I guess it's both. You want to validate both the from type and the resulting type. So you could add these guards to make sure that everything is fine. And if something is not fine, then yeah. So this is just a void. But we do. But in that case, we do actually need. More information, maybe? Because this type doesn't encompass like the whole thing. Then we need like to keep the context of the entire thing as well. Okay, I'm not gonna do that right now. That's a lot of stuff. I just want to make this work and then fix runtime errors. So why is this happening? We have to debug here a bit. So we check the. There's no persistent data that has this type. So the only thing that I'm thinking of is the string Z. That's the only thing that has it. So what if we do it's just, you know, value object and then value object straight up into an object here. And then the field, and then the resulting type is supposed to be, so it's a pointer. Wait. It's this maybe, but no, it's not this. But it could be this. So let's say this. But I thought we did. But I thought we actually had this covered. Upgrade object. No, let's see. So we have the upgrade value. So we're going through and seeing the source is a pointer. Is it the source that's a pointer? And then the element type, let's see. Found that. Field type T minus. So let's say the first object is the document, the second is time map. And we are at layers. And we're checking items. Which should be a slice. It might not be this one though. That's the issue. Wait, aren't we doing pointer to string Z? Is that the thing we're doing? Is it this one? Is it just... No, because it's items. Oh, it is in this function where things go wrong. So it's like, yeah, you're trying to access... Is it in this? This where it goes wrong? So let's say the file path is... First, it's a pointer, and then this is a string Z. This is where it's trying to access what? Man, I wish I had. I wonder if they're gonna add like debugging to the comp time, so that you can loop through or like see what's happening, like debug while it's compiling and see the steps taken in the comp time stuff, because it feels like that should be something that should exist later. That would be an incredible feature to have. I just don't see why it should go in there. This is the present data, so it's value object. Okay. Then we have this value object. Okay, so maybe it's just thinking this is that. Why would it be value object? This, because the source is a pointer, but then this is a string Z, so it should be an object. So that shouldn't. Final value. And then up here with the standard upgrades we have the string Z. I don't understand where it's going. Let's just go through all the persistent data here. So time up check texture. Oh, it's just this one. Scene. No, it can't be any of these because no, it's too deep here. It's like happening straight away. This doesn't have any of that. Wait, is this unmanaged or not? Yes, it is. Okay. Cool. information. Then that would be like a list upgrade. Maybe it's this one. No, it's like the target is. I mean, I think in this maybe, but then it should match string Z. And whoops, entity type version 1 name. Oh my god, this is the problem. Okay, I'm stupid. Yeah, these. Okay. We could add that validator. We could add it, so we could say that was a stupid mistake. Okay. Let's just add a rudimentary validation. Where's the main upgrade function? Here. No. Here. So validate. So the from type is always gonna be an intermediate type or a frozen type. Let's just call it intermediate. Right. So we're validating that. We want to check if t is equal to string z. Just straight up. Then we're gonna have a compiler error saying intermediate document type cannot. So invalid intermediate document type. Type name T. So now we know, like let's say, let's run. Okay, of course it's crashing. I wouldn't expect it. Okay, at least the compiler errors are gone. But I want to say now, okay, let's change this to a string Z or Z or whatever. And now we run, and we should get a compiler error one way or another. Wait. What's the error? What's this error? Oh. Well, let's change them both. Invalid, so yeah, so now we get this. Invalid, intermediate document types. Now, it would be nice if we could see the whole, which original type it was from. So you get like document 0 dot blah 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 dot blah blah dot blah blah. So you can see exactly where it is. But this is probably very good for now. And you do get, at least you get, right, if we run this, get the compiler, at least you do get some indication, but you don't really get which document it is. I guess you do get by searching further down. I should have done that. Okay, so here we can actually see which type it is. Yeah, actually they should be all available because we do have everything. Like document type is like comp time. Well, I don't know if it's exactly true, but yeah. Now at least we have this. We should also not have this. Well, I guess we could just do we don't allow that. Yeah, now it's going into the string Z, so okay, cool. What else do we don't allow? We don't allow string Z hash map. We don't allow any of the sort of current persistent stuff. Okay, but anyway, that's gonna be good enough now. Now let's go back here and change this back. I can remove string Z. Oops. Okay. Now that's all good. All right. Now let's check out what the crash was. Okay. Error parsing missing field. So it's missing some kind of field. Could not load document foreseen. Missing field. So which field is missing is interesting to know. Properties. Missing field. Yo, baby Yoda, how's it going? What's up? I'm I've been down a rabbit hole here. Basically, what happened was I have all these data files, so tile maps, and I changed the format from using a 1D array to a 2D array. And then I had a brilliant idea that I was going to implement a version control system, or not a version control system, but more like a version upgrade system, or a migration system, whatever you want to call it. So yeah, I've been doing that and doing this very like generic code in Zig, which is it's really fun, but it's been a long road here for implementing it, but it would be cool if it started working here. I've done I'm past the point of compiler error, so right now I'm investigating a runtime crash. I don't like generics that much. Okay. Well, I have tended to avoid like doing generic comp time stuff because, well, one big reason is that LSP doesn't really work that well with it, and another reason is that, well, there's not really many use cases for it until now with the version upgraded system. But the issue is that I don't want to have to sit and implement the same thing over and over. That was the thing. So I have made this sort of generic upgrade system that takes it can take an object of one type and turn it into another object of another type if the objects are basically the same object. Well, yeah, this is it's not really for Gamedev, I guess. This is more like the editor data files. It's you can equate it. I think it's more like if you have a database and you have a certain schema in the database. So you have like a table called users, you have a table called I don't know, something, and they have types. You have fields and you have types on the fields, but then all of a sudden you need to change something, so you have to then write a migration script or a migration code to actually migrate to the new schema. If you have a running database that's live, you have to, like, and you want to update it, you have to handle that migration. So if you want to add a field, then you write a script to like add a field to all the things while you upgrade it, and it's kind of the same thing here. So I've basically written sort of the architecture around the upgrades to do an upgrade stuff. You can do that just with structs though. Well, I can show you a little bit on how it works and why I've done things that I've done. I mean, I might have just, done a whole bunch of unnecessary things, but at least I've learned a lot of things on the way. So let's see. Well, I really want to fix this error here. Why is there a missing field? Well, okay. Let me show you a little bit on how it works. So we have, if we start at, let's say this one, for example. I'm telling you because I had the same problem before so many times. Yeah. I mean, yeah, I hear you. I'm just gonna show you here how it works. So we have time map data, which is just it's a time map. It's the persistent data. This is basically the mirror version of the JSON file. So you have now a version which has been added to all the documents, where we keep track of which version it is, and if it's an old version, we upgrade it to a new version. ID is just ID and time map and history. So all of this is stored in a JSON file. Now the version here is important. So if we go, so all the persistent data follows, like you could say, an interface. This was more, well, this was more involved here, but essentially we have a list of upgraders which upgrades from the first version to the next version. So depending on which upgraders you have here, it's actually gonna you're gonna get a compiler. Let's say I wanna make a breaking change. I can bump. Here's the current version of the document, so I can actually bump this version up. Now I'm gonna get a compiler error because it's not really a nice compiler error, but it's an indication that, oh, you need to upgrade it's complaining that we are missing an upgrader here. So you actually get compiler safety with this system, which is nice. Anyway, it works. So that's one thing. But then, yeah, we basically have also I made a dependency injection system where you can create a container that upgrades certain types. So this one, for example, handles up like adding the history. So right now I don't have the history defined in the sort of other version, so I need to add the history here. So I take this type, so it looks at this type, which is document 1, so that's version 1, and then we have the fully realized like current version, that's the result. So the dependency action looks at the from type and the to type, and it matches that with whatever is required, and then we can just and we're gonna run this function, and you can just return the result here. So that means that, for example, we could, yeah, if you just want to change something deep in the object or whatever, we could define a function for just that object. So let's say I want to update the tile structure. I could just define a function that takes the old tile and updates it to the new tile, and then it will automatically work in this upgrade system. So if we look at the upgrade, like the entry point to the whole thing, we have this, well, almost the whole thing. This is like where you call upgrade value is like a very generic thing that upgrades anything to anything else, basically. But it does so by, you have this container where you have all the dependency injection information, all the functions that you've defined for what upgrade functions you want to have. But then it also has default upgrade functions for various things. So for example, we have for structs, we have upgrade object, enums, upgrade enum, union, and basically these are just, you know, they just basically copy the value, because if you're gonna upgrade an enum to a new enum, we just assume that the old enum is the same as the next enum, because if it's not, then you have to have a special updater for that. So basically, well, first we check if we have a dependency injection for that type, for this type of upgrade, and then we just apply that upgrader and we're done. If we don't have that, then we go ahead and do the generic version. It is a bit overcomplicated. It is overcomplicated, but what I like about this is I conjured this up in my mind and then I just did it, and that's what I like about programming. Like, you can just do this, and it doesn't necessarily have to be the best thing. It doesn't have to be the most optimized thing. The important thing is that you learn from it, and that's how you learn what not to do and what to do, you know. So it's like, and I haven't really put this system to test, but it's nice that it's there, because now I don't have to define, in the future I don't have to define a whole bunch of stuff. But it could lead to other problems. It could lead to problems where it's hard to maintain. It's each time you have to go in this code, you have to basically go through it all again to understand how it works, and then go in and fix a problem. So it's not that nice in that sense. It's nice if you keep what you're doing inside this box, but as soon as you want to go outside the box, then it's going to be really hard to actually upgrade. Yeah, JSON is not really a good idea. Okay, but I mean, it's just why do you say that? I mean, I'm just using it as a data. It doesn't really matter what I'm using as it, because the thing is, the whole point of this editor So it's not that it doesn't ship with a game engine. That's the whole point. So that's why. Well, I'm not using a JSON library. I'm using the standard built-in JSON. I guess you could call it a library, but it's the standard library. But it's like the whole point of this editor is to not ship with an engine, so that you're using it with your own engine. And that's why I export things into JSON files, so that you can import them easily in whatever fashion you want. So that's the whole thing. And and I mean, you can store it in whatever way you want, but JSON is a universal thing, so yeah, that's why I'll do that. However, this part is not really, I mean, it's like this part is, I mean, it's not really have anything to do with JSON. It's more having to do with upgrading the different versions. If you go and look at one of the versions here, let's say this one for example, like this is document 0. It's defined entirely in struct form here. So what I'm doing is, if I find a version of a saved file that is the old version, or as is this 0 version, I can read it in using this struct. And then basically this struct will never change. It's always going to be the same. So this is frozen. This is supposed to be frozen now, frozen in time. And so I'm reading in the old version, and then we can just upgrade it to the new version. What is this? Content manager for content management for Halo 2 and beyond. Content management. Oh, 39,000 files. Okay, then we're good. We had to build custom tools to effectively handle content management for Halo 2. Even simple constantly just in time editing game assets, simply loading data from days to turn complex piece of implementation at that scale. I did something similar to this in my program C++ to turn out better than JSON. It allowed not to depend on that. Yeah, I mean, sure. You know, the thing is, the project is designed to be like, you save it as a JSON file, because then you can use whatever programming language or whatever you, basically everything supports JSON almost. So you can read in the JSON file and use it in your project. So that's the whole point. And then if you want to have, but because I don't really have like hot module reloading, I don't have like, if you update an asset, it's gonna like automatically go through all the pipelines and go through, and you can immediately see, you know, the result. I don't have that built in to the game engine, but in theory I could build that system into the game engine, and then I also have to build that system into the editor as well, which should be probably part of the roadmap. But that could use a whole, that is probably going to use a whole other protocol, which could be JSON as well. That could also be based on JSON, like you push in, you send an event through the network or something. Like you could even have like, yeah, you can even have like network. You the client list, like the game engine listens to a network and loads in the files that way, and then the editor is the server that pushes things through the server like that to the client. So that could also be a thing. 4 OS compatible. Do you mean the thing that they're doing here? I haven't really looked at it. Just use IDs to identify parameters or your struct members. Yeah. You just need ID, type, and address. I mean, yeah. I mean, okay, so if I explain more, the problem here is like, if you, let's say you save a project, and then the editor is updated. So okay, I'm not saying I'm gonna. This is like super important for me right now because I'm the only one using the editor, you know. But if let's say, but and that's why it's like I'm not saying that this was important to do right now. I'm just saying I just did it for fun. But it would actually be important if you have other persons using this editor and they make projects and they save the project, so now it's a version 1 or whatever. Then I push a new version out and they update the project, and all of a sudden the documents have an updated version, so you have to somehow upgrade that project into the new version, right? That's the whole thing. So you have to have like a migration thing from the old version to the new version. That's what I'm doing here. From the type you can know how to serialize, deserialize. Yeah. As games become more complex, as hardware limitations have less and less impact of the quality of game, future game innovation will come less from technology and more from content. For the purposes of paper, content management is the process by which you create, organize, and access non-volatile data necessary at runtime to drive a game engine. Content management applies to both runtime users and persistent storage of game assets. For Halo 2, we were fortunate enough to have a mature, persistent object system that handled all of our resource management. That's an extra feature on top of your save file, I guess. I'm just talking about the basic idea. Alright. Yeah, I would have to like read through this to understand what the suggestion is here. Like what would be like, I have a problem and I'm solving it with a version upgrade system, but what would be the equivalent of the thing that you showed me here? If you change the name of a key in a new version, you still have to migrate the old config file. Yeah, if I let's say do you mean a key? Do you mean like I change a field or I change a key, the name of a field? So, for example, if I change, let's say I change entities to entity list. Do you mean like that? Or what do you mean? Play position, yeah. So that's also possible with this system, because you can just define the first version as this, and then I define, so each version is defined here. So we have version 0, version 1. Version 1 is just basically a copy of version 0, except that we add version here as a field. And in this thing you can, like, let's say I want to have entity list here instead, then I can actually define an upgrader for that will just do that. So it's not an issue. So I can go, let's see, here's my upgrade from 0 to 1. So instead of doing .entities equals to previous entities, I would do entity list equals to entities here. Yeah, and the whole thing here is that I keep the information about the old types. So the first version is forever available here. This is the first version of the document. So every time the version bumps up to the next version, I will add a new version. So all versions are stored here as structs. Frozen in time. So that's how I can load. That's how I can load old versions into the program. So we're loading in the previous version or the first version, and then we're upgrading it to the next version like this. And how does it know to move the key? Well, and if I change this to entity list, okay, so now the version 1 has entity list and version 0 has entities, right? And so then I have my upgrader, which only works for version 0 to version 1. So this is the upgrader. So it takes the previous document, which is version 0, which has entities, and then we return version 1, which we just define here. We just set this like this. So now it's upgraded. So basically, let's say we're at version 10 of the documents. So now we have 10 different versions. Now an upgrader is defined for each version, like an upgrader is defined for version 0 to 1, and from 1 to 2, and 2 to 3, 3 to 4, and so on. And so the upgrade system will automatically take those upgraders and apply them in sequence so that you get to the latest version from any previous version. And then we just keep this history so that no matter what version you're using, you can always upgrade it to the latest version. If you update the editor, it will be able to update the versions as well of your project. Unless there's like a major update that sort of revamps maybe the entire thing, maybe it's not possible to make an upgrade, but at least for things like this, it should be very possible to just keep on going like this. And also, well, another thing is that sometimes you have things that like cross across documents. I don't really have that right now, but it's very possible in the future that you have breaking changes that will be like you don't really have the it's not really contained in one document type, so it might be several document types that have to be upgraded together. And if that happens, then I'm basically going to use the same system, except I'm going to apply it for just a larger scope. So that should just be that should actually not be that difficult. Now we already have the system in place, so we should just be able to like define new struct that has all the documents that's needed for upgrading, and then just use that as a thing, and then we can get the new documents upgraded for that. So I'm not sure if you understand here. I'm not really showing the entire thing, because it's like we also have like, you know, the thing that actually runs the upgrades as well, which is it's here. So let's say here's like the generic document code, and wait, do we not call this? Yes, we should call. Okay, yeah. Okay. So here's the deserialize function. So here's where we actually load the file, basically. And so we have a directory and a path. And so and here we initialize the document. So we have persistent data, this is the data that we're interested in right now. This is the data that we load in from the file system. And so we have this function here. So this one, well, we read the file. So we read the entire file here. So we don't have to read it like multiple times if we have. It's just a quirk here with Sig here. I would really rather like be able to read just the header of the file and not have to read in the whole file. But that's just a stupid optimization thing. Anyway, never mind. So we're reading in the file, and then we allocate space for the data of the file. And first we're checking, okay, are we supposed to upgrade this document? And if we are, then we upgrade it and we get the new data and we populate it. Otherwise, we just read in the data as the current version and populate that and return that. So we either like do an upgrade if we detect if it's an old version, okay, and then in here we first we read a document version header. So this is basically like a mini version of the file, the whole file, and the JSON library is able to just read that part, or it doesn't read just that part, but it does read the whole file. But it does just, you know, parse this field. So we're parsing just the version, okay, and so we're kind of forcing all of our documents to have version, which is fine. And then we're checking here, okay, do we have a missing field error? That means that the version field is missing. So that means that we're at, you know, a version that doesn't have the version field, which is like the oldest version you can have. So then we do an upgrade from that, from basically the first version. We could also get some other JSON error, which we are reporting here. Otherwise, we have a version that we can read, and we just check if it's less than the current version. Then we do an upgrade as well. So let's check what's happening in here. And so, yeah, we're basically doing some sanity checks for if the version is less than the current version that you're trying to upgrade to. And we also have this like convenience thing, first document version, which is always 0. But we're just doing some convenience check here. And then we're basically, here we're reading in the old version. And how that works is we can actually get a comp time known type here. So we're checking from version, which is like the version that we've read. So it's either like the first version, which is version 0, or you read like this is the version that is in the JSON file. So let's say it's version 0 or whatever. Then we are doing this switch here. This is like a inline switch case with a range, which then this is basically copying this code inside X amount of times, depending on how large this range is. So it's gonna grow in size, but it handles each version case from that. I mean, you can argue like right now it's not a huge deal, but it might be a huge deal if you have like 100 versions or something. But then we could probably have more generic code here. But anyway, so now we get the upgrader, and this is actually like comp time known, so we can get the upgrader from here. So the upgrader is basically it's one of these, like these functions here, this function here, for example. Okay. Well, actually, it's this whole file here. So you have document previous and document next as well. So you know which version is previous and which is next. Okay, and then so you know the previous version. So this is the entire point of this, is to figure out which type do we need to parse in, which type is the JSON format in, or the JSON file, which format is the JSON file. So we take the type that we think that the JSON is, and then we parse the file with that version. So now we have parsed the version that we see that it is from the version number. Okay. And once we have that, we can go ahead and upgrade all the steps in between up to the current version, which is happening in here. So we're upgrading from 0 to 1. Let's say we're on version 4 or something. So we upgrade from 0 to 1, from 1 to 2, 2 to 3, and 3 to 4. And then we also do a final step where we, because the last version is actually just a phony sort of version. It's one of those frozen versions. So you take the frozen version and upgrade it to, you realize it into the final version, which could have more advanced types and stuff in it. The intermediate versions actually just allow, is very strict which types they could have. So they only have a certain amount of like primitives and string types and stuff like that. So we can automatically like upgrade them. The intermediates basically is pretty simple actually. Well, first it just checks if we only have one upgrader, then we just apply that and we return. If we have more than one, and this is just, I do this just because the compiler didn't understand, well, the compiler complained here that we had duplicate cases. If both are 0, then we get like duplicate cases for some reason here. But if they are both not 0, then we don't get. I think that should be probably a bug in the compiler. But let's continue here. So we this switch here is also pretty interesting because it uses a new feature in Zig version 0.14, which is label switches. So label switches is basically, I mean, it's basically like a while loop, except it's sort of like a state machine. So you start with this state here from version, and then you have a case match here. So let's say it's first document version, or like in between, or the end version here. Then it goes ahead and goes in here and upgrades that version. So let's say we start at version 0. So now we get 0 out here. It's gonna match at this one, which is 0. And we upgrade from 0 to 1. Then we do this break, upgrade, and 0 plus 1, which is 1. And when you do break upgrade like this, like break onto a label with a value, it's actually going to go in here again in the switch. So it's like a loop. So it goes in here, but now the value here is v plus 1. So first we start at 0, now it's 1. So it's like a loop, you know. And now we match the 1 here. So now we go from 1 to 2. And so on, and the next one is 2 here, so we go from 2, so now we upgrade from 2 to 3, and so on. Yeah, and then once we reach the current version, which is matching down here, then we're done, so we just return. And the thing that we're changing is this input here, which is a pointer to a yeah, anything basically. It's like a void pointer almost in C, just so that we can represent all the different types, all the different intermediate versions. Can you tell me for those fields how you track which ones from the old version match to the new version? So basically, let's see, this is the next function. So in here we have the version, which is comp time known. So this is like 0, 1, 2, 3, etc. And then we have a list of upgraders, which is also like a comp time list of these types. And so we get this upgrader, and the upgrader itself then has the information to be able to upgrade to the new version. So it has the, which again is this part here. So you get access to these 3 things. So the upgrader is basically this entire file. So you can access the previous version of this specific upgrader, which for the first one is 0, and next one is 1, and then you also get the actual upgrade function that you need to call in order to upgrade to the new version. And so once you have this, what we do is we first we cast this current pointer that we have to our new or to the previous version, and then we create we allocate space for the next document. We populate it with the result from the upgrader. And here's also interesting here, because we're using this upgrader function, and what you can do is put in a container, and this container is like part of the dependency injection system. And when we're doing an intermediate upgrade, it actually turned out that we needed a special container for that, and we need a special scope for that. So I'm putting in this intermediate container that will handle all those cases that we want to have. And then yeah, we're done with the previous version, so we can destroy that, and then we just yeah, get the next version here. And so we do this for every step between to the final version. And then in the final version, or at the final step, we do this. So we take, this is document final is basically the frozen sort of version of the final document, which is, I mean, let's take scene here again. So this is, no, not this. This is the current version of the scene, persistent data. And then you have scene, whoops, then you have scene version 1. And this is the latest of the quote-unquote frozen version. So this version corresponds 1-to-1 with the current version, but it's in this sort of constraint. It has these constraints on it, where the entities have to be a slice with a const of the entities, and so on. So it has these constraints, but the final step is to upgrade this to the current version that we can use in the program. And so then we upgrade it to this version. So this is an array list instead of a slice. You know, it's it has these extra things, and that's what we're doing with the final upgrader. And then but basically we're doing the same thing. We're taking the final document. So this is the previous version that we will need to use. We cast, so we get a pointer to it. We also need the sort of, I'm taking the value out here, so now we have a local copy of the value. We destroy the pointer, and then we do an upgrade value. So basically its upgrade value can take anything. So it takes the final document, and we want to upgrade from the final document to a persistent data, which is the current version of the document, of the persistent data. And we're using another container now, which is designed to take those highly constrained types and turn it into the final result types. And those also have constraints on them. So we know, well, if you define the documents to be in a certain way, this should always work. That's the whole thing as well. So they have to be defined in a certain way, because we're assuming a lot of things about the types. So we're assuming the intermediate types look in a certain way. They can only have certain types, and the final result also has to have a certain types. However, you could extend it. So if you need to support more types, then you can just extend the containers with those types. So yeah, it was a lot, but it was fun to build, and it is extendable, and we can also extend it to like cross documents and stuff as well, like project wide upgrades, which I think I'm gonna lean towards if we get there. If we get the first time, we're gonna get a breaking change that needs to handle cases across documents. I think I'm gonna switch to like a project wide versioning system instead of like each document has its own version. We're gonna have a project version, and if you have an old version of the project, you need to upgrade the whole project to the new version. Okay, there was a lot to but hopefully maybe some clarity there. I don't know. But yeah, so but now now I built everything, but now we have like runtime issues. I never actually tried it out until now, so we do have runtime errors. Oh yeah, we also have these temporary changes. Yeah. But it's not really that big a difference than the order of the members doesn't matter, because the JSON file, when it's read in, it populates whenever it finds a key. It just populates that field. It doesn't really the order doesn't matter. But that's part of the standard library, and it's kind of how JSON works. You cannot have a guaranteed like order of the things. The only problem is if you change the key name. How do you mean? Which key? Well, it's not a problem because we can read in the old version and then update it to the new version with and then change the key in the process. Like see here, this upgrader, it's taking in the previous version here, which has, let's say the key is entities, and then let's say the next version has changed the key to entity list. We simply do this and it's done. This is the part where we do it. This is like we're taking in the previous version and we're returning the next version, and we're just mapping the values here. Yeah, we have to write some things manual, and the reason here is because we're adding a field here. I'm adding version, so I have to supply this field. That's the reason why I have this. So I have to supply this field, and in the process I have to basically just fill in the rest. But since they haven't changed, I just pass them along like this. Yeah. But actually, if let's say the next upgrade is so trivial that it's only the version that is updated, well then you can actually you should be able to just have a generic function for that, and you can just do that. But I mean, you have to do some implementation here. This is but it's basically the same as migration script when migrating a database. However, it would be nice if we could just I don't know, add fields and you have documents, I don't know, and like the previous, and then you add a field called version and the value is 1, something like this. So it would be nice if we could do this, or if we could embed it in the types somehow, and that would automatically sort of do it for you. But yeah, that would be maybe in the future. The thing that's here right now is sufficient enough for it to be way better than the first version that I did was basically I had to do a lot of the logic that is now automated in every document, but now it's a lot of things that we so actually well, yeah, let's see an example where we actually use the upgrade value. Well, it's for the final version. Yeah, the final version is automatically upgraded. So we can automatically upgrade this version into, let's say this is scene persistent data. We can automatically upgrade the version from the left to the version from, we can automatically upgrade this version to this version, which is really nice. That is automatic. We don't need to write anything for that. So it's automatically, when it encounters a slice, it has to be a const, and then some type in there. It automatically knows that, oh, I should create an array list. So it just creates an array list. And then when it encounters this scene entity here, it also like automatically goes through each field, and it does everything recursively here. And then you have scene entity type, you have everything. So everything here to the left is automatically turned into the thing to the right here. Which in this case, they are basically the same thing, except the left part is very highly constrained, the right part is constrained in a different way. But yeah. Let's see. So yeah, we have to manually write, or I have to manually write the upgraders for the intermediate upgrades here. So from documents here to document 1. But then the upgrade from document 1 to the persistent data, the final like type that we're using in the program, is automatic. And the reason why we want to have them different is because the intermediates are sort of we don't want to keep we want to keep them frozen. That's the whole thing. So we don't want to rely on types that might change in the future. So basically we have these frozen types, which yeah. So that's why. Now I'm sitting here wondering what the missing field is. It's pointing to the properties. But there's no missing field there. I was pointing. It could be a one-off error here. Because I made a report thing. Yeah, demo thing, but it doesn't say which field. That's the thing here. It's a missing field. It doesn't say which field it is. I'm not sure if you can turn on better reporting for the JSON stuff, because the problem is that SIG's error system, you can't really return data in the error. You just get a string. So basically, and the string is like static. You cannot have any custom data built into an error. It's just you get just the error name, and sometimes you want more data, and but then usually perhaps the JSON system has a way to report that error. So I'm just gonna check here. This is in document generic. And also I wrote this little idea with an automatic breaking change checker, which basically you serialize the current version and then you try to deserialize that version with the previous like frozen current version, and if that fails, then you have a breaking change basically. Now so that could be good to have like an automatic thing. I'm not gonna do it right now though. I'm just gonna have to remember that if I change the persistent data in a way that will break, I have to remember to update the things. Otherwise it's just gonna break, I guess, when you try to load it. Which is done now. So, but let's see, where are we doing this? This is like, yeah, it can't load any scenes. That's the whole thing here. So we are I think we are trying to upgrade it, but it's missing a field pointing to properties or beside the properties or something. So missing field. I'm wondering which field it is. It doesn't feel like this should be an error that comes up. I'm perplexed. So which log is this? Error parsing JSON, requested document. Could not load content. Why is an error happening in here? Well, it's gonna be this, I think. Deserialize. Yeah, and you know, then it goes and calls deserialize document generic, which then goes and calls this, and then calls. We're reading in the document. We are trying to upgrade it. So maybe we should have a catch here to like upgrade document results. Catch error. Could not upgrade document. Come on. Okay, and this is what path I think it's called. Where are we? Path and error. Turn error. And then in here we do if we got a result. All right. So it's very interesting because it's like it's a little bit, you know, I'm delving into the comp time stuff of SIG, which is very interesting and very helpful. But you always have to think about these things before you decide to implement them, because it's like, is it worth it? Because as we've said, like, you could get into a situation where it's very hard to maintain. It's very hard to go and fix something. You have to like put the whole system in your head before you can actually understand what you need to do to fix a problem. And the larger the weird system is, the harder it will be. Yeah. But if it works, it might be worth it, you know. And I've had the sort of philosophy in this project that I was not gonna do these things. I was not gonna, you know, over engineer and do weird stuff like this. But I don't know. I let it take over for a bit there. Not found. Loading. Error parsing. JSON 785. Yeah. Could not upgrade document. Here we go. So we do get in here. Okay. So it is in here that we get the error. I'm basically creating my own sort of stack trace, it feels like, here. So this is where it fails. I think. No, the header works, I think. It should be going in here since we're not since we don't have a version thing. We're trying to read the old version. So is it here that it's, yeah, let's just add some logs. Could not read old version. Oh, we don't have the path here. Okay, I'm just gonna do this. Error, return error. Could not upgrade intermediates. An upgrade final, funnily enough, does not have an error that it can be. Anything happens in here is basically going to be either a compiler error or an allocation error, like an out of memory or something, which we just ignore. So okay, let's see what this says. Could not read old version. Okay, so it's missing a field in the old version, and this is for, I think, a scene. Yeah, it's, wait, or is it property? No, it's a scene. Yeah, it's scenes, demo, swamp area one. Okay, so it can't read the old version. Interesting. So let's look at the old version here. And I think it's complaining about the properties here. Is it like something should be nullable? Like here, the fields. Oh, wait. Hang on. Scene, persistent data. Let's look at this type here. Custom properties. Yeah, this, okay. I did a thing here. This has custom serialization and deserialization, so it's actually just, it doesn't have fields. We just serialize it into an object directly. So we actually, this whole thing is actually this. That's what it is. Okay. Okay. Yeah. And if we look at version 1, it should be the same thing. Yeah. Okay. I was kind of hoping it for magically work there, but oh, we have. Oh yeah, so now we get an error here. So let's see. We're upgrading an object. No, we're not. Okay, I think we have to change our matcher for that particular type, perhaps. JSON array hash map. Yeah, we have to change. I have a matcher if it's that type or not, which is these two. So no, but that's, wait, no, that's not. Wait, now I'm confused. I gotta focus actually behind the work. Okay, cool. Yeah, that's good. It's good to get things done that you have to do. I'm sorry that you have to do it. Yeah, it's very warm. How were you also Swedish, or I forgot if you maybe we haven't even talked about it. But it's really hot now. It's like how many degrees? 23 Celsius. It's pretty hot for this country. Canada. Okay, yeah. Cool. Then you should have like almost. Isn't that like almost the same? Zone or whatever. I mean, how hot is it in Canada now? Or where you are? $24, $30. Oh shit. That's there was some I don't know why, but why Canada was subject to like heat waves. Maybe it's something to do with the location or something. I don't know. The climate. Yeah, okay. I have a fan. I'm not sure if you can hear it. Yeah. Okay. No field name fields in array hash map. So where is this coming from? Version 0. Why does it think it has fields? Is the question. But this is also a problem, like finding. This is the same problem with like event-based system. Like it's so hard to find where like a trigger happens somewhere. It's you don't see the entire picture. You have to like byte-wise find all different places where things are happening. It's like, especially if you're not used to the system. So this is kind of I see this as kind of the same problem here, we're getting some error, but now we have to figure out, okay, where is this error happening, or where does it come from? I mean, we do get a stack trace here, but it's actually it's the scene again. Okay. Oh yeah, of course it's the scene. Of course. It's the final upgrade. What? Wait. Let's go to scene. Did we forget to bump the version? Is that the question? No, we didn't. Okay. Do you still... I mean, you're using the same data here. Properties. Hang on. Yeah, so we need to convert an array hash map. Yeah, an array. Oh yeah. So we need to convert an array hash map into. It's the other one. It's the other container. It is this one. This thing. So. Oh, so it's not matching here. That's the issue. It's not matching because the target is different, right? It's not... Oh, string Z array hash map. Oh, that's what we need. Oh, that is what it is, right. Yeah, we need to match a string Z array hash map and not a JSON array hash map. That's the issue here. So what is the difference? I don't think there's much of a difference actually. So what kind of project do you need to do? Let's see. No, this is wrong. Wait, where is it? Here. We need to make this type. This as map. And then this has entries. So it's the same. It's basically the same thing. So it should actually work. It should actually match here, I think. Wait a minute. So, okay, this version, which is the final version here, this property object has this. We need to make a property object and not as, okay, okay. That's why it's not matching here. we actually need to supply a special case for this. So we need, alright, so we don't need a from array hash map to a string Z array hash map. We need an array hash map to a property object. That's the problem. Right. So let's just add that. So then we go to upgrade. Now, I mean, we can just change this type to a property object instead. Oops. This is sort of the built-in. I need to organize this a little bit better. Property object. Okay, we actually run into a little bit of a problem here. And that is that the property object can actually be like several types. We have like one version for each. I mean, granted they are the same version right now, but what if it changes? Okay. Okay. I think we'll have to live with this for now. I'm gonna do this. I mean, we could you could also change this into supply this in another supplier, but I think I'm gonna have it here. And property object 0 is, well, it's gonna be documents scene version 0 dot property object 0. Okay, so that is what we do. Because the array hash map, the only array hash map we have is for property objects, because they are dynamic and they can change. So that's why that's the only thing that we have. Yeah, and really this matcher here, if we match our array hash map, then that has to match to a property object. So actually we could probably just remove this 2 element, but we need the 2 element though. That's the problem. But the 2 element is basically going to be property, right? Well, actually, we don't need 2 elements. I don't think. Yeah, we don't need it. It's not even. Yeah, we don't have it here. This is going to be property object 0. Which oh, we have ID. What the hell? Wait, what? Wait a minute. Wait, where's the ID? No, the properties. This has an ID, not the property object. Wait. Oh yeah, okay. So it's a hash map of a property. Yeah. Right. So why does it think that it needs an ID here? It shouldn't need an ID. This is an array hash map. Array hash map doesn't have an ID. Okay, now it says map. I mean, isn't it just empty? Does that exist? No. Map equals empty. Yes. Okay, so we can do this. You know. Yeah, so it's just an array hash map, basically. Except we don't need two elements, because we already know it's gonna be property 0 that we haven't actually defined. Oh, it's defined down here. This is property 0. We need property 0. Okay. Where's this? Here. Yeah, property 0. Why didn't it complain there? Maybe it did. I don't know. Wait, no, it's not this one. No, where is it? No, it is this one. Wait, did I change the wrong thing? No, I didn't. But why doesn't it complain here? Yeah, that is correct. Okay, so what is it? Expected type, nullable function, allocator, hash map, version 0, property 0, contain property 0. Yeah, that's the property object 0. Okay, and then return a property object. So this is a final upgrade. No, it should be. It should be 2, 1. Well, except it's the same thing. Okay. Found function allocator, array hash map, version 0. Yes, that's the same thing. Upgrade container, that's the same thing. And then return the same thing. Okay. Wait, this is wrong. Here we are. What? Found that thing. Let's do a thing here. Spec. Yes. Cast into return time. This fine. Where is this happening? Upgrade 150. Yes. 12 from 212. Yep. And this is the final upgrade. So why is it getting... Okay, let's see. It actually goes to 150. Oops. Which is this match function. Which is the correct match function. It's the correct match function, yes. And now 2. Yeah, property object, attachment. Yeah. Yeah. Exactly. Type of source T. 2 from yes. Match from 2. From 2, yes. How could it find this type? Wait, what the hell's this? No, this is... Yeah, this... No, wait. No, wait, this is wrong. It's not property object 0, it's property object. What the hell? Okay. I don't know what the hell I'm doing here. So it's property object. Yeah, okay, I don't know what the hell I thought there. Okay. Fields, map. Sure. Fields. There we go. This is a string set. Okay, I put the wrong thing in there. Okay. Anything else? No? Oops. Okay, let's try it. Nope. Whoa, what's happening here? Out of bounds. Wait, missing field?
How could it be out of bounds? Wait, return error on the field. Oh, but then the cat caught it, I guess. Inner parse. Field default, struct values. Missing field. Index out of bounds. Okay, I've never seen this. It gets index out of bounds in the parsing function. What? Okay, I need to order some food. Guess I'm hungry. There we go. Okay. Why is this happening? I just need to make my move here at a board game. No, not that one. Wait, why isn't it showing up? Okay, whatever. What do I want to do?
this is perplexing. How does it go out of bounds? Where is it going out of bounds? Like the last thing here, it says like return missing field, and then somewhere it goes out of bounds. It doesn't show where it goes out of bounds. So this is like the latest. Okay. No, it's this. $384, and then it's returned. Well, let's okay. Well, it's not going to be a field index. Wait, it's returned. Where are we? Parse, inner parse, okay. What the hell? Read next. Is that the thing that happens? But that should state. Wait, error parsing on infill default structures. Hmm. Is there something wrong with the... I don't understand. Why? Where's the index out of bounds coming from? Like this just talks about this thing. It returns error missing field, and then somehow we have index out of bounds. What? Okay, so let's check JSON here. Yeah, it's like it feels like it's something's happening here. We're trying to. Oh wait. Is this it? Ah. Oh, is this out of bounds? Oh, this is out of bounds. Okay, that makes more sense. Okay, that was a bit scary. Okay, I think this is the place where it's out of bounds. We're trying to add padding. All right, that makes sense. Okay. So let's just do. I mean, this should really be like, okay, what is this? Com time int. What is this? U size. Okay, so it can't even be. I mean, I think we have to do like. Let's see. So it's either gonna be padding or cursor, whatever is the minimum, I think. Wait, so if padding is greater than cursor, we want the result to be cursor. If so, man, I always confuse myself with these things. Minimum we'll take the smallest. So if padding is smaller than cursor, that's fine. If cursor is like 50, then it's fine that padding is 50, let's say. If cursor is 20, if padding is 50, then we want cursor, yeah. So it has to be min. Right. And then we have end, which is the same thing, except for the end. Well, here we can actually just do plus padding, but then the results will be and I believe it's exclusive, so we can use length there, yes. I think. Yeah. I'm just gonna assume that's the start. Yeah. Alright. Okay, good. Alright, still crashing here. Well, still index out of bounds. Okay. But why? Start to end. So is the cursor like... Okay. Is the cursor... Father... Okay, I'm confused. Like, I don't really understand this cursor and stuff here. I might be totally wrong in assuming that the cursor is... Wait, max? No, this should be min. Min. Yeah, because... Yeah. Oh, it went further this time. Okay. So error requesting things, unknown fields. Okay, unknown fields. History. Oh yeah. So I mean, either we could just remove history from the old versions because they. We really shouldn't have unknown fields, right? Maybe we should just fill in the versions, I guess. History. Well, I guess from if they're frozen in time, we can just assume that the old version will always be correct. So I guess we could, when we load in older versions, we could just do unknown field if this was the case. So let's just do that. Document generic, and we're loading in the old file. We can just say ignore unknown fields. Oh, what if it works now magically? No. I feel like it's close. Huh? We get some different error now. Requesting document. Missing field. Again, this stuff here. Assertion failure. Is it a catch unreachable somewhere? Or is it an assertion failure? Oh, here. From versions less than current version. Oh, okay. So which document is this? Is the question. Which document? Which type of document? Texture, okay. Texture. Let's check. Ah, because, okay. So here's the issue. We haven't bumped this version. Should we have a double check for if the current version matches? Yeah, we probably should add as much help as we can to this system. So we could actually, if we go to document generic, and we're reading the old version. Oh, I guess it's before this here. We don't have, well, actually, no, because we don't have, yeah, but it also happens in there. So it's in here. We should have a check somewhere here. This is we're asserting here, but we should have a check here that checks that current version matches the final upgrader. So document final is this. We should also have final upgrader. Okay, and then this one is just final upgrader. Document next. All right, and then wait. Final upgrade. So let's validate current version equals final upgrader. Yeah, and that's just a thing that we do. Basically, this could be done like at any point in time because it's basically I mean, it's basically like a comp time check. So we'll just check here. Actually, can you call a function here? Can you just call this? No? Container fields? Okay, let's just call it there. Okay, fine. So, we need a final upgrader. This is gonna be upgrade, final upgrader, persistent data. So that's the final upgrader. Actually, this is not what we want. We need final version, final upgrader version. So this, I mean, we're basically doing this. Yeah. Final upgrader version. No, that's, well, it's a document version actually. Oh, we don't have that here. Okay, now we have it. So we're checking if final upgraded version, this is all comp time as well. If this is not equal to the current version, then we have an error. So current version of what let's just do type name persistent data. Current version of this does not match final upgrader version. There we go. Oh shit, and now we catch a whole bunch of errors. Nice. Look at this. It's beautiful. Okay, so now we know we have to update these things. Actually, this doesn't make sense. There's something wrong here. They shouldn't say, these are the ones that are correct, I think. So the final upgraded version, it should probably be like +1. That's right. And then this is like the previous one. There we go. There we go. Now we get the correct ones. Okay, so animation and texture does not match the final upgraded version. Okay. Nice, then we know exactly what's wrong, and next time we bump the version or add an upgrader without bumping the version, then we're gonna get this error, catching that error, so that you will know exactly what to do to fix the error. Awesome. Instead of hunting down this issue again, you don't have to do it. Okay, so let's go to our dear texture thing and just double check that we have everything here. Looks nice. And we bump our version. Maybe we should actually have a function to do this instead. It's not that big of a deal. I'm not gonna touch that right now. Okay, and now we just need to fix the animation persistent data as well. Let's check the upgraders. So here we have our upgrader. Yes, everything looks good here. And we have our container. Maybe the container should be like optional, because we already know how to create it. So it's like if it doesn't exist, then you don't really need it. But I guess it's good to be there so that we can easily see like how it's supposed to be used. Okay, but anyway, let's just bump this version here. And there we go. Cool. Now let's see if we run into something else or if it's done. Oh shit, it works. Oh my god, look at this, and the time map looks correct. This is the time map. This is the actual time map, and now it's like a 2D array. Wow. Okay, but if let's say we quit. Let's say anything. Did I add anything about upgrades in here? No. We should probably log that out. Like if something is has to upgrade, then we log that here. Info maybe, I don't know. Upgrading document. Do we have like get ID or something? No. I mean, it should exist on persistent data, so well, we don't have the ID. That's the thing. Well, we do have the ID because we're reading the thing. So we should, but we haven't read it yet. We just have the version. Okay, maybe we should read the ID as well, so we get that like a header information about what we are doing here. We should also have the document type, but yeah, because now we don't really know, okay, which document is it, but maybe it will be apparent because of the logs, because the logs say, okay, we didn't find this document, so now we are reading it or loading it, and then it's gonna say, okay, we're upgrading this from version whatever to whatever. From version this to this. And since they are like integers, we don't need to worry about decimals. From version and current version. Alright. So we start. Alright, and we check here and we say upgrading. There we go. Upgrading document. Yeah, it's basically gonna upgrade everything because we're loading everything that we're loading all the scenes and all the time maps to build the map. So it's upgrading all the documents. Now let's say we save. So this is forest entrance time map. Let's open that up. Maybe I should make a backup. No, it's not a way. 05013. What? Oh. No. There we go. Oh, that took a little while. Strange. Okay, but anyway, so yeah, so projects, time lapse, forest entrance, just the first one. So we're opening this up. Oh man, it's like huge. No. Takes forever. Okay, there we go. And also, since it's one line, it's also taking forever. Like Vim has a really bad time reading files that are one line and like huge. But once it's done like this, like line by line, it has no problem. So, and the reason it's huge is because, as you can see here, these are the tiles. And they are in a one-dimensional array. And each tile stores an object. This is far from optimal here. So each tile stores a source, which is either null or it's a reference to a tile sheet and also a tile in that tile sheet. And we also have is solid, which is like a hard-coded thing right now. I mean, it's I don't think we even use this actually, but it's for the game to know if it's gonna be a solid thing or not. But this actually I mean, this should really be up to the game to determine. But or we have some other structure for that. But let's see. And here's how a tile looks when it actually has source set, which is like each tile set is like a string here with the ID and then the grid position to say which tile in the tile set you have. So it's a super unoptimized way of storing the thing. So that's why maybe it took a while to copy the thing, because now we have a lot more tile maps. Okay, but anyway, now this is stored as a one-dimensional array. Oh, it takes a while to actually find the... Wait. Oh yeah, and also we have one of these huge lists for each layer as well, which here we have like 5 layers or something. So anyway, that is the old version. Let's actually open up the backup for this, which is 713, and then time lapse, forest entrance. Yeah, I'm gonna go just through the same thing again. I have to enable sound on my phone as well, so I don't miss the food. Alright, let's see. Here we go. So we'll save this. There we go. Now we can. Now this is how it looks. Yeah. And let's change to the other one. Right. So now, wait, is that the same? Still takes a long time to, I guess, open for some reason. Yeah, I think it's like the LSP that's stuck here. Is this the same document? Yes. Okay, let's just do this. So now it's not the same. Okay. So now we launch and see when we save, the right one should change into a two-dimensional array. So we save this. There we go. And now, well, NeoVim has to update here. Probably the LSP is gonna crash again or something. Oh, wait a little bit. There we go. It's gonna have to load in the whole thing. There we go. Now it's updated. I'll change to that window and save so that it reformats the thing. Okay. And yeah, I mean, you already seen we open it up in the editor, it works. But here, well, for one, we have the new version here, so that works. And we also have the tile in now a 2D format, except it says items here. That's not good. That is not good. Okay, that is actually an issue here. Let's restore the file. Yeah. Okay. Okay, so now it's restored, and there's an issue here. Let's open up a new tab. We'll go to time. Persistent data. Why would it store it like that? That is strange to me. Is it because we changed the type somewhere and we forgot to add the parser maybe? Now here we have our like generic JSON serialized in these areas, and they handle, oh wait, oh sorry. Okay, food is here. I'll BRB. Alright, I'm back. It's good to get some food. Okay, where were we? Alright, so yeah. I think I know basically why this happens. Basically, we have array list of array list here. Now we do have the JSON stringify, JSON parse here, but they don't really handle like double array lists like this. Maybe they should. Parse, right. Let's see. There's also a little bit of generic shenanigans going on here. So we're checking there, we're doing fields, yes, right value field. If it's a pointer, now we're right and all. Okay. If it's a pointer. No, we're in right over. That's right. Yeah. So we're going through each field. Huh. Wait, where's the thing happen where we have array lists? I am confused. Wait, right value? Oh, here, we're calling right value, that's right, okay. And here we have a list of some kind of value type. Yeah. Yeah. Now let's say the type inside is also an array list. We probably want to catch that here. Like we can look at the element type of items because we assume that items does exist. It feels strange to add it here, but I guess it's fine. Can't really catch it otherwise. Okay, let's just do it. Let's check. Okay, let's do element is element of type of array list of items. And if, okay, so basically we have to do this again. If the value, if element, wait, yeah, if element is an array list, then this is like the writing of each element. Otherwise we're writing raw. So we actually have to, I think we have to like where is this happening? Like parse, inner parse. Calling it with any type. No, we want to. No, it's not parse. It's stringify. Yeah, JW is this thing which returns a write stream, and this has. Do you have anything called array or what the hell is this? Wait, stringify. Stream. Oh, there should be something called. Yeah, begin array. Okay, here we go. So we'll do try begin array. And then I guess try end array at the end. We will loop through items, and we will call write function, I think. Is there any special thing we need to do? It doesn't look like. Let's try it. Right, so okay, let's try this again. And we save. It crashed. Or well, it did something. It looks like it works. But then it crashed when exiting or saving for some reason. Oh, did it not finish the entire thing? Mm-hmm. Strange. Okay, let's check the error message. Unreachable code. Object key expected. Interesting. So is this... Oh wait, what the hell? Okay. I'm writing it again? Okay, that makes sense why it would fail. It feels strange. I mean, okay, yeah. It makes sense though. Okay, save. Oh, it did not crash. But it, okay, something happened when we exited here. Or is it just that Vim is loading? No? Okay, looks like we may have leaks. Or not. Or we do, yeah. So we do have leaks. So I'll check that, but first I want to check the data file. If it's stored there. Okay, cool. Here we got the data file here. Let's do format. Maybe I should have tried like a smaller version first, but yeah, now it looks good. We have an array of arrays. In each array we have now all the values here as well. It looks very good. Okay, cool. So that works very good. Yeah. We have a working upgrade version system now. And we'll see if it's gonna be the bane of my existence here, but yeah. Let's remove these things. Okay, let's check out this leak here. Where is this happening? Array list. Okay, reader, file reader. Okay, interesting. Read. Okay, so it's this thing that is apparently not tidied up correctly. So where does it come from? Here? I mean, we just defer free that, and then we're done. Don't need to keep it around or anything. Is that the only thing? Let's see, because now this version... Oh. Actually, that's also interesting. We haven't tried loading the new version. Unexpected token. Right, we need to do the same for the parsing as well. Okay, yeah. Okay. This is gonna be a bit more involved, I think. The parsing for... Like, we're parsing the object. Here is the parsing object. It's gonna be a little bit involved. Not that much though, actually. So we're actually just parsing as a different object, that's right. Okay. Yeah, we're creating a type here. Element of array list. Yes. Return null. If it doesn't have field items, return null. Yeah, okay. And then we get the thing there. Switch items. So I think actually we wanna recursively parse this type. it's not. I don't know if it's an object. Yeah, it's just gonna return T if it's not an object. What if it's what if this type is an array list? I think here I'll try to do like a very generic serialize wrapper that basically turns any type into this like serializable version, which you could do. I basically want to do this. Well, what we could do, we could go meet halfway. So we could say here what the hell? If this is an array list, we will break no wait switch items pieces. No, if child, yeah, if child is an array list, you wanna do slice of that because that's the child, yeah. We're wrapping it in another array, and then we're recursive calls it. So we potentially can have any number of array lists that are nested like this. Okay, let's see if we can successfully parse. No? Still errors. Segfault. Ooh. Draw function. Okay, so we're actually successfully loading the thing. But there's something not really working here. There's something in here that fails. So we could put a whole bunch of logs here if we want. Could not load project. What? Wait. Document tag not matching. What? Wait, document tag not matching. I mean, that's not a load project problem. Oh, well, it could be, I guess, if this is called in there. Why would that be happening? What are we requesting? Okay, I don't understand. Like, we create this, we open a file, we read the file, we parse the file, which is an project options file. Yeah, it's this file. How does this return that error? That doesn't make sense to me. It could be happening in here, I guess. Yeah. It's probably happening in here. And it doesn't. Well, it finds. I guess it finds a tag, but it doesn't match. What? This makes no sense. I never thought I'd see this. I'd see this error. Okay, let's do this. Let's do catch error. Could not generate scene map. Could not. What was this? Okay, so then we get could not generate map. Okay, so that's happening there. But then first we get this error. Error parsing JSON unexpected token. Source null is solid. Which token are we talking about? Oh, now we're getting like multi-line stuff happening. So what is the unexpected token? Maybe it's like the array list happening twice. It could be. It seems like this is probably the place where it complains. Yeah. And since that, okay, our system actually, if there's an error loading a document, it's gonna store that as an error in the document state basically, and then when something else requests the document and that document has an error, then you basically don't really get a document out there. That's going to be an error as well. So that's why probably we get this error down here, but then we get like a seg fault. Maybe, I'm not sure why we get a seg fault though. Maybe because we're trying to draw the time at that. Maybe because we're trying to open a document that is an error. So we should probably fix that as well. Like if you try and open a document that is an error, that's gonna be a problem, you know. So we have requested. Okay, so let's go to context session and we go to restore session, and we go down to the part where we check for, yeah, here's open documents and open editor. So well, it's basically gonna be the same thing. We try to open the thing. So if we have an existing, if we don't find it, we request it. Otherwise we just set it. So here we actually, we need to yeah, we need to have a case for if a document was not loaded properly. So yeah, this is gonna be like if we did find an existing, but the value has an error, or like what is this actually? No, that's not correct. I think it's like if state equals to error or something like this. Right, if it's error, if it's error, then we don't do anything. I think we just return. Let's see, because we shouldn't really crash at this point. It should just fail silently. Wait, do we have an editor? Oh, I see. So we don't, wait, we don't have an editor, that's right. So we don't have an editor, okay. So we don't have an editor, we'll request a document. If we don't find it, we just remove the editor. But we should also remove it. So let's get the results here. If we get a result, we can use that. No, wait. Yeah, if we get a result, but then I mean, I basically want to do this, but I don't want to copy this. Okay, we can do this. This would be our sort of exit from out of here. And we do this. If we get a document, and then we check if the state is, but the state is error. Then we do something, otherwise we do this. Actually, if it's not error, we just do this. And then we fall through down here, which is like an error loading document. Yeah, let's just do this for now. I'm not gonna worry about how good this looks right now. I just want to get this working. We can fix it later. Why is it a novel? This, okay, it's a, wait, oh, documents. So now I should preferably show it as an error in the thing and not crash. Okay, still crashes. Could not generate map, could not load project. Right, so if we could not generate the map, should we just not care about that? We did load the project, like we did, but oh wait, do we have defiers here? No, we don't. We're loading the options, we're loading the index. The thing that doesn't work is this. But I don't think that's gonna be like, let's just do this. No, still crashing. Could not generate map, and then it like false. Is it because the map is like not done? It shouldn't be an issue because it's like null and empty, so well, What about this? This is null. Is it really that there's that's the issue? I'm not sure if it is. Alright, let's just not render this. Okay, we still get issues here. Does it still try to open this thing? Let's see. So it's doesn't find an editor. We're trying to request a document. Okay. If we get an error somewhere, yeah, I have an error there. Open up. Yeah, there's something with error parsing JSON. Yeah, so we're in here. And we are opening the thing. Could not open document, so could not load document content. Well, I mean, it's gonna be happening in there, so and if something goes wrong, then we set the state to error, but we still have, like, yeah, the document is still it still exists, you know, but it's in an error state, so that's fine. And well, if we have an opened editor ID, we opened it, the last thing here. If this, at this point, we shouldn't have an editor because this should have been cleaned up and removed. If there's an error loading the document. So we're requesting the document. Either we get a document or we don't. But if we do get a document, it could still be in an error state. So we check here. If we get a document and if it's not in an error state, then we populate the editor with the document. We also set the current editor to add to that, and then we return. We're done. If we did find the existing, we just set this to that. But if there was any error, either if there's no document or if there's an error, then we fall through down here where we remove our editor and we do that. So I'm not sure why we get an error now. let's try do this. Let's try opening up the session.json, and we try to change this to null, and then see if we get the same error. That means it doesn't have anything to do with like the open editor. Yeah, but at least we did try some cases there. I think that actually was a case that we really had, like if we open up a document that actually has an error, then we didn't handle that, so now we actually do handle that, so that was good. But something else is going on. Could not generate, so it is like after we could not generate CNAP, but that's like the last thing that's happening. Also, it's weird that document tag not matching. That's a super weird error to get. The tag is not matching. It's like, why is that happening? That's super weird. Tag not matching. So we're switching on that, and we're checking if it's the same tag. If so, it feels like somewhere we're calling this. Wait, it should be comp time though. Shouldn't this be caught in a compiler error? This should really be like a compiler error almost. No, because we're loading in the document content, that's right. How can there be a document tag not matching? Where is this happening? We have a million places where request document by ID is happening. So it's not really easy to find. Well, actually, maybe not that much. So we have thumbnails. Oh, wait. Maybe it's the thumbnails. But, I mean, we are catching it, so... I don't think so. I mean, we're doing a whole bunch of stuff in scene map. Let's actually just disable this loading the scene map at all, and we'll see if that's the issue. Let's actually just disable this. Yeah. All right. So we still get... Well, we're not gonna get could not generate scene map. We'll still get segfault here. Alright. Interesting. Interesting. Right, do we get do we still get the document tag missing thing? No? Okay. So maybe it's because... Okay, I don't know, but okay, so that problem disappeared basically when we did this. Fine. Let's disable that for now. And what else? Well, okay, let's check this out now because we are layout generic. 34 draw function, which is this. But then I went to the time map because that's what was opened before. Now it should be okay. Let's do this. Let's open up the session again, and I think what we'll do is we'll just delete all of the opened documents. Okay, and then we'll try and open something here. So here we go, unexpected token. Okay, this works because we're upgrading it. So interestingly, that works. Oh, but when I exit, there's a crash. Okay, that was the error parsing. There's a seg fault when deinitializing persistent data. Okay, let's check. So this is the only document that's open. Okay. We'll try. Let's close this. Okay, still looks good. We open it again. Close. Okay. So the issue is with the upgraded document. It's with this one. We open it, we close it, and there's like a deinitialize error. Okay. So there's an error opening it. Why are we like deinitializing? That's the thing. Is this like really? Did I really miss that? No. If there's a state error, then we just return. Could not load. Oh wait. Okay, let's check document generic. Could not upgrade document. Return the error. Okay, but we're not upgrading, we're parsing it, so there's something wrong happening. Here, I think, yeah. Because we're not, this should be null, so we don't need to upgrade it. Because if we did, then it would say trying to upgrade, I think, yeah. And so it's in here where it goes wrong, and we're doing a try, so that means we are in this part, and here we're also doing a try, so it bubbles up to here where we also do a try. And when something goes wrong here, we set the state to error. So, and it does say here, could not load document content for that thing. So, and could not open. So why? Do we want to add deinitialize? Okay, let's just add a log here. Initializing documents. Okay. What? Yeah, so we are going in here. Why? How can the state have changed? No, okay. It doesn't actually log. But yeah, okay, and you know the ID, it tries to go into content to find ID, but the content doesn't exist, so okay. Initializing document state error. What the hell? What? We're checking for error here, and we're returning if state is error, and then it goes here and says, yeah, We're initializing a document with state error. What? What? I mean, I don't have... There's no multi-threading going on. How does this happen? What am I missing here? If the state is error, we return. Then it goes to the next one and says that, yeah, it's error. What? Am I missing something super obvious here? It feels like I'm missing something very obvious. What if we move it here? We'll say, okay, this is 1, this is 2. Yeah, okay. Does this make sense? Is it because it's like a thing here? Like, I'm pretty sure this is... You're matching the tag here of the state. And not like some value, but I guess, yeah, because maybe... I'm pretty sure you could do this, like matching the tag, like this. Did I understand this wrong? Oh, this is this, right? There's something weird going on in my... Okay, there we go. So, where is it? Switch? No, union, tag union. Switch, yeah, you can switch on it. You can do this, okay, sure. You have to take the enum thing. Maybe that's why, I don't know. Switch variant. I mean, I guess I could try a switch. Is that it? I thought that you could do ifs on it as well. Okay, and opaque. I've never understood how to use this. Used for safety when interacting with C code is not exposed structure. Okay. Okay. If with optionals. What about if with... Oh, you can do if with error unions. I didn't know that. Okay. So could you do this instead of catch? Like this is... I mean, it's basically the same as catch. Right? Almost. Yeah, okay, so... Okay, so maybe there's other places where this is totally wrong. Okay, let's do a switch. Now I'm pretty sure you can do this. Okay, now let's try. Otherwise you would have to like spell it out and say, okay, you have to say the actual enum value there. Oh, it still crashes. No, it's still... I thought that this was pretty much the same thing, but let's try this. If this doesn't work, I'm following the manual or the documentation, then I don't know what's going on. Still crashing. Unless we found like a... Okay. Maybe we found a bug in the compile. Okay, let's do this then. Instead of this being any error, let's make it into like a struct that has the error in it. That is the error. Could we do this? Is that a thing? Looks ridiculous. But it might be that because it's like directly an area, I don't know. Oh, still crashing. Or am I missing something else? It feels like this shouldn't happen. What? Its state is but what is the well, okay, so what is the actual content? I guess we'll do any. the hell? Okay, is it something wrong with like saving the error? Like is the error not, can you not copy the error value, or what is going on? Any error refers to the global error set. This is the error set that contains all errors in the entire compilation unit. The union of all other error sets. Okay, fine. You can coerce any error set to the global one, and you can explicitly cast an error of the global error set to the non-global one. This inserts a language level assert to make sure the error value is in fact in the destination error set. Okay. The global error set should generally be avoided. Okay, because it prevents the compiler from knowing what errors are possible at compile time. Right, knowing the error set at compile time is better for generated documentation and helpful error messages, such as for getting a possible error value in a switch. Right, well, I understand that. Okay. Error, so error union, maybe we can use an error union type instead. I'm not sure. Maybe there's like a special weird case here where it doesn't actually match this. I don't know. This is very strange, but let's try this. Let's try having the state be an error union. And then it's like any error or something, I don't know. There we go. If okay, so I guess we'll do self dot well, actually I guess we can do catch wait. State equals self.state catch and then we just return the error here. So okay, no, we'll catch the error, and I guess we can return it. Or do we want to silently? No, we're asserting here. So, and then we can assert that the state is unloaded here. Okay, so let's do the same thing here. If this is not, if this is error, then we assert so that it's gonna crash anyway. So we can just return error. Okay, there we go. Right. If we catch this, it's basically saying this is not possible. And then we check this. Wait, actually no, it is possible. It could be error. So if it is error, then we don't care. Actually, we should care. Wait, how do we do this? So it's either going to be an error or so is okay is if we have a thing, we check the state should not be loaded, otherwise we catch the error, except yeah, and then it's true, except we don't need the error. There we go. So that should work, right? And then we assert that we are okay. Expected optional type. Okay, so we have to do this, I guess. Okay. Right, now we have an issue here, so I mean, let's just do this and Annie. Well, actually, yeah, let's just do this. Okay, but then what we want to do is we want to say state equals self state, but if there's an error, we just want to return. Yes. We can do this, I guess. It's ignored. Yeah. So let's ignore it. Okay. I mean, that's the first time I'm actually using an error union as something that we save, which it does make sense to have that as like a additional, like it does actually make sense if you just need to store like one type of, like store the thing there. Okay, so I guess now this would be like we grab out the state, else we have an error. But if we have an error, we don't really care. And I'm gonna reorganize this whole. It feels like we should invert something somewhere here, but I'm not gonna do that right now. Okay, and then we have if this is unloaded. So if it is unloaded, yeah. What I'm trying to say is that how would you do this? Like we could have an if. This looks a bit weird. We have an if here. Otherwise we have false because it's error. So it looks more weird here, but okay. And then we have this one, which is like if it's an error, I guess we could do no. Is it like error? Is error from in the name? How do you do this? Let's do like else state equals, so it's like entry value pointer state catch return null. That would be equivalent. Okay. Oh, did I not show that? Oh, whatever. Time app. Below this, please work. Oh my god, it works. But there seems to be leaks now. Okay, so that was okay. Wow, is that a bug then in Zig? Maybe that should be like reported. Oh my god, 3,400 issues. I mean, they are actively working on stuff. Maybe it's bad to add more. Holy crap, that's a lot of issues. Stuff. Let's see. Error type. Error in union. No, it's not a label switch. Okay. I don't know. Never mind. I'm not gonna deal with that right now. So what do we do? Okay, let's just fix this memory leak. Okay, header parse, parse from token source, document generic 125 here. Okay, header parse. Oh, we're not actually deinitializing it. It's a proper arena initialized as well. Okay. Yeah. Wait, why wouldn't that show up? For strange. Okay, now we don't get memory leaks either. Nice. Okay. Cool. It works. So, okay. Let's enable this. Oops. And project. Load options. No, it's not load options, load project. Session project. No, context project. Here we go. Okay, let's see if things go wrong now. Okay, so we cannot load the document. Some document is unable to load. Can we open the scene map? We can open the scene map. So, okay, we can see there's a gap here, which means this is the thing that's... And that is actually this thing, yeah. So that can't be loaded. Let's see, do we get any... So actually the scene map turns out to be pretty robust. It just... there's just a gap where the scene that failed to load should be. Okay, cool. So, all right, let's. Okay, so now we need to figure out why does the error happen. Okay, so yeah, it's the double array list here. Okay. JSON. So it's like why? Oh wait, this doesn't work. Is this like an infinite thing? Wait. So we're going in here. We know it's an array list. So we're checking the items. We're going into here, we're checking if the thing is a pointer, which means it should be like another array list or something below. Okay, and so if it's another array list, then we make another layer here and we grab out the next element of array list. So child is now an array list, and we grab out items again from child, and items is there, and then we do the same thing again. Okay. So what is that? So what if it's not a pointer though? What if it's like how did this work before then? Yeah, that's weird. Because it's... Okay, hang on. It's not a pointer, yeah? But it is an array list. No, that's the source. Wait. No. We're not checking for... field type dot items. Yeah, it is a pointer, of course. Yeah. Dot items is a pointer. And then we get the pointer, and then we get the child. Right. And so we get the child. We check if that is an array list. And then we do this again. Yeah. So, yeah, now this is an array list. We go and check the items of that. We go in here again, we check if it's an array list. We break if it is. Well, it's not. Well, yeah, it is an array list. So we go in here again, but now the next time it's not an array list. So now pchild is not an array list. But then we don't go in. Wait. Right, so if it's not an array list, wait, but we know that this is an array list, so this time it works. Yeah. So we went here once. We know that it's an array list. We check if child is an array list. Then we do this again. We know it's an array list, but now it's not an array list. So then we just do this, and that should be fine. So I don't understand what the issue is. Okay, you know what? Let's improve the error message a little bit. Let's go to JSON, report error. Now, I think I want the start to be, we want to scan the entire line. So when I get the line, is there a way to like do that? Index. Backwards. Okay, so we could get the end of line is gonna be reader scanner cursor. No, input to from scanner cursor to index of scalar position start is why don't I say read? It's reader. Let's just do this. Input to reader, scanner, input. That's just the slides. And then we have cursor, reader, scanner, cursor, which is just the U size. Okay? So then we do input, cursor, input, cursor. Value is new line. What if it doesn't find it? What happens then? Nullable. So, or else, we're just gonna do input.length. Okay, that's the end of the line. Now we need the start of the line. Start of line index. So I'm just gonna loop. I'm just gonna go from, I don't know. I'm gonna go from cursor. No. I'm gonna go from 0 to input length minus cursor I think that would be like yeah, so start offline index if input I is equal to this break I guess I plus 1. If we don't find it, then it's just gonna be 0. So start of everything. Okay, and then we have start of line is equal to input from start index to cursor, and then no, what am I doing? We don't need to do this. We just need the index. So we just need the index. And this is exclusive, yes. And so then, and then line is equal to end of line. All right, and then we can do line. Yeah. And then this would be, how many spaces do we need? Just I mean, no, this is gonna be start cursor minus start offline index, I think. Because it's, yeah. And there might be like a one-off somewhere. Forget the padding. We might include... No, we don't want to include... well, we could include like other lines, like maybe the previous line, but no. I'm not sure if we want to count to the sort of line numbers or anything like that. Wait, why did we get all this? Oh, wait. Input, this is gonna be cursor minus I. No, still shows a whole bunch of stuff. So input, okay, so input length minus cursor. This is like from the end to the cursor. That's not correct. This is gonna be from 0 to cursor. Yeah. We're gonna go backwards all the way from cursor to 0. But it still doesn't work. So we're going backwards. We're checking if it's that we're breaking. So why isn't that working? Oh, it's because the index is wrong. This has to be cursor minus I plus 1, I guess. What? Okay. So let's wait. How? What? Why? Do I have to say -1 here, or I thought that this was like exclusive? Okay, but it doesn't make sense. Well, it does make sense if start is larger than end. Okay, but now it doesn't show anything. From 0 to cursor, we check the current cursor position and we go backwards. If we find an end line, we break with cursor minus I. That's the index that we're looking at. That's gonna be the start. But it should really be +1 because we don't want to include the end line there. But then somehow that actually caused an issue. Why is that? And if we don't find anything that the start is 0, that makes sense. Why is it basically empty there? It should be a bunch of spaces. So I think now start of line and end of line is like the same, or almost the same, because if I add 1, then start of line is going to be greater than end of line, and then this is actually going to be like an infinite loop here, which will cause an index out of bounds error. Except it doesn't make sense because it says 305. They're out of bounds. What did it say? Start index 306 is larger than ending. Okay, yeah. So it wasn't out of bounds. Okay, so they actually fixed this because in the earlier version, it went into an infinite loop. Okay. How can it be larger? I'm trying to find it. Is it because cursor is standing on top of a... It's standing on a thing. Okay, so we should do 1 here. 1 or cursor. What if cursor is on 0 though? If cursor is 0, this will also be like a error. Well, we could do this and we can say -1 here, but what if cursor is 0, then it will become like an... No, if it's 0, then we don't even go in here, I don't think. Yeah, it has to be larger than 0. Yeah, but we do need to add 1 here. Okay, let's try this. Well, it didn't crash. Here we go. Okay, now we get this here correctly it's formatted here. Okay, cool. So there's an unexpected token here apparently. Does it not expect an array here? It's the question. It's the question that drives us. Okay. We are moving forward, but it's going a bit slow right now. Yes, but we got a lot better JSON reporting now. which is really nice. So the issue is parsing. Yeah, it's parsing the thing. We're only worrying about the shallow object as well. Except there's one part that's not shallow in this part here. Yeah. And the wait. Right, if field type is an array list, we make this. What is this? If the child of this element is also an array list, we do this again. So the result should be like this, and then this results in this, but with the child being wait. Okay, let's do it. So first we call this with like this element of array list, and the field is also an array list of something. So when this is evaluated, we return another thing of array list, but now the child is something here. But something is an array list. No, something is not an array list. But this is an array list. Yeah, it is an array list. We go in here. We grab out the child. Let's do this. Array list. So lm array list. Okay. So we're not calling this. What the hell is this? Oh. Let's forget about this shit here. Okay, this doesn't return null. Like, okay, so element is lm array list t. So when we call this, we already assumes t is an array list. Okay. We're grabbing out the child here, and we're checking, is this also an array list? Then we want to return a recursive call like this, But if the element, and then we go in here and again we grab the element from this array list. If that is not an array list, then we just return the element. Okay. Actually, this would be just return. And now up here we can just do that. Okay, let's see if it works now. Nope. Yeah, still the same issue. Wait. Yeah, okay, so we're checking. Do we have an array list? If that's the case. Okay, I think this is, wait. No, it's an error here where we're actually parsing the thing. Yeah. So we're serializing an object shallow. So we're basically we're creating a serialized type, we're taking a type of an object, and then we're basically we're basically taking all of the fields in the object and making a new type where those fields are serializable, basically. And so we're going through the fields here and we're checking, are you an array list? Because that's basically the only thing we need to check here. Are you an array list? Then we set you to a type to this type here. I guess it makes more sense if we had a function that is like to array list. And so then we know that field type, we know that this is an array list. Wait, no, it's not to array list. Wait, what am I saying? It's to, so array list to slice or serialize array list or whatever. So we know that this is an array list. We grab the element. We check if it's an array list. And then instead of doing this, or I mean, yeah, we're gonna return a slice, but then here it's like if the element is also an array list, so that means we have like a nested array list, then we make a slice and then we call this recursively again, except it's array list to slice instead. We call it on the element again. Now this time the element is an array list, but when it goes in here we get rid of the element of that array list, and if that is not an array list we just return a slice of this element. So the resulting type will be slice and slice of element here. Okay, that is more, I think that's more reasonable thing than to do this weird thing. Yeah, I think we'll just remove this. Okay, and then up here we do array list to slice. Okay. But here it's gonna be a bit different. Wait, we're taking... No, this is wrong. We need to do it here as well. This is like the next step. We need to do it like the other way around. Well, let's just do let's just do this. Slice to array list. And now we can use this. And we can check if this is a slice, I guess. If it's a pointer, if P is, what is it? What's it called? Size? Okay. So if the element is a slice, we return an array list. Slice to array list. Alright. Now here we do slice to array list. Okay. Oh, is this still like the element? Wait. Oh, init array list. Okay. Wait, so field.type, right? Field.type, but that should be then. Shouldn't that be a slice? Which function is? I think this might be the result type. So, why couldn't we just do this then? Right. Array list, arrays on yeah. Okay. So now we need to convert like recursively here as well. So here we need to check if is array list. No. But yeah, we need to do this again. This is an array list, so we want to check. Wait. Put this out here. We want to check if we're creating an original here. We need to call this recursively in its array list. So we're checking here. If yeah, we need the element. No, it's gonna be element of array list field. Field type. Yeah. There we go. Where is this still? Oh, it's over there. Okay, so we're checking now for the on the element itself. So if the element is an array list, we do that. Okay, and then we have the function. And so this is going to be the element, right? The serialized. This is the serialized, yes. What is the parsed object? Why do we? Oh. Oh, we're setting it. Right. Okay. So actually we need a separate function. So we need to do like I don't know, create array list. I don't know what it's called. Now this one should have. Oh, let's just copy everything. We'll figure out. Actually, you know what? Let's copy all of this. Okay. So this is going to be the array list. I don't know what we will return, but we're gonna return this, and once we have all that, we can simply here we can just say just read error there. Yeah, we're just gonna try create array list. There we go. Okay, and then now we can reuse this function, but we do need like comp time. So we need this. We need like the resulting. Let's say this is the resulting array list. So we're gonna return that, and then we can simply do this. We need the serialized array. Now the serialized array, what type would that be? I mean, I guess we could just provide the type, I guess. We could do that. Let's try it. We could also say any type. But let's start there. We also need the allocator. Alright. What else do we need? I think we don't really need a serialized object. Oh man, okay, we need a separate okay. Okay. I mean, that should be everything we need, right? This is almost like we want to use our upgrade system for this. Like actually deserializing. Yeah, I guess, I mean, we could. Parse object is basically... Well, we already parsed it here, so... Yeah, we're... No, no, yeah, we should. This should be. We should be getting a full object from this. But then we're trying to do. We're trying to initialize the result as well. So we're turning like array or slices into array lists. But I mean, we could just do that with the upgrader. Now. If we go to upgrader, and we, for example, we have the default upgrader here. I'll just provide the standard upgrader. This is gonna be upgrading to string z's, which we Okay, this is actually a bit weird now. We have basically two different entry points. Into parsing the JSON. So we're parsing. So either we go from the JSON to the document frozen version and then upgrade it, or we go, and that requires like its own parser basically. Or we upgrade directly from, well, or not upgrade directly, we read directly from a JSON into the current version. That's because that's two different sort of pathway. I mean, because the frozen versions have different representations of these things. Like, it doesn't have array lists; it has slices. But the final version actually has, or the current version has array lists instead of slices. So we have two different ways to deserialize basically a JSON. One is into the intermediate types, and one is into the real sort of type. But this standard container is meant to upgrade from an intermediate type to the final type. And so yeah. So maybe we should, because we could easily load it with the frozen version first, and then use an upgrader to upgrade that to the final version instead. Yeah, I mean, why not? Then we can scrap the whole parsing thing. Okay. So here, I mean, we're trying to parse this directly. I mean, what you also could do is, like, if we have a nested, like if we have a 2D array, we could have a custom parser just for that, I guess. But here we could, well, I think we can solve it by like parsing it into the final version and then upgrading the final version. So we could do, because then we only have like one entryway into actually parsing from JSON into some sort of constrained type. So we're reading an old version, and this version is gonna be the final version. So for example, if we have one upgrader, it's going to be version 1, so it's going to be the final version. And so we're reading the old version, and then we are right, but then this assumes that it's the previous one, so that doesn't work. So we have to actually do final version -1. But then we're reading the wrong version actually. Well, let's just make a convenience function. Read as version. And let's say the version is, so now it makes more sense to have a versions array instead of an upgrades array. I mean, I guess we could turn it into a versions array. I guess we could do that. We don't really need the upgrade function here anyway. Versions. So document versions. Okay. Now we're basically gonna, I mean, this is all comp time, so we're basically gonna make versions here. This is a list of types. I'm sure if we need content scope here, but I'm just gonna add it just in case. So we're gonna go through the upgrades. And let's keep track of the index. And what I'm gonna do is I'm gonna first just equals, I'm just gonna do this. Where did we do that? Here. Okay, like that, so okay. And this is the upgrade document previous. Right. Now at the end we also want to add the latest version, so we're gonna do document next on the final upgrader of versus there. Oh. Yeah, we don't need either. Yes. Okay. So we need the document type is gonna be upgrade versions, and then the index is gonna be v. Alright, and we don't need upgrader. This is the version that we're gonna use. So now we can okay. Now the old version here, we can also, like, we can say we basically return read as version. I mean, it's basically the same thing, right? So we don't really need to say old here. We can just say read as version, and wait, yeah, we still want to do that, and then file contents, and then this is as version or version. Alright, now we can say goodbye to you, and this is goodbye to you. Now, right, this is the final document, and then we say persistent data equals upgrade final. And the current is this. What do we get? We get a pointer here, yeah. So we upgrade final. Does this take care of the old pointer? Yeah, I think so, yeah. So we're parsing, well, we're reading this in, upgrading it to the final thing, and then we're done. Okay, so it is an extra step, but I think it's fine because we're sort of doing several steps in here anyway. Yeah, especially cloning. So I think we're basically doing almost the same amount of work, if not less, actually. Unused constant. Oh yeah, now we have like a whole fleet of arrows here. I think we'll just undo everything basically. Wait. We don't want to undo this. Okay, let's get... Okay, I don't want to do this. Okay, this is fine. But then for parse, it's not fine. Like here. Yeah, so that's fine. Okay. Now what is this? Scene is no member named upgrades. What? Upgraders. Wait, how did this work? Wait, or is it just that it's called upgraders and not upgrades? It's called upgraders? Okay, it's called upgraders. Okay. Expected. Oh. Why? Is it only here? I don't understand why I don't get it. Why? Oh, it's because it's const. Okay. Yeah, and of course this is returning this. There we go. Again, it has to be const. There we go. I mean, it's kind of weird. Like, okay, I guess it makes sense if you want to be able to modify them. But how would you append to a mutable list? Maybe you can't. Okay, let's see. I'm not hopeful, but hey, it did not work. Wait, do we have leaks? Okay, I'm not gonna worry about the leaks for now. I'm gonna worry about this unexpected token. Okay, now the error reporting is wrong. Did I mess something up now? -1. No, that should be fine. So let's say cursor is at the new line. Then this should find it directly. This should begin at -1. Huh. Okay. Strange. I'm pretty sure this is exclusive, so if it's like, yeah, length and then the input of that which we don't want to be there. Do we have, well, it looks like there's a new line at the beginning, so that's why it looks weird. Okay, so then the start should be like +1. Is that what we're missing here? It has to be +1 here. Okay. Yeah. Okay, so we still have the same issue here. But what? Wait, what? Why would this be but? Okay, let's check this leak here. In the meantime, that's JSON stuff. Okay. So the previous. Okay. Oh, this one that just returns. Yeah. So it should take care of the version of this. So what is the why? We're creating it and then we're returning it. Yes. What's the issue? Actually, we should. Yeah, we should ignore that. Novice maybe. Well, yeah. Doesn't seem to happen all that much, but we are only loading in one, I think, document here. Well, we are actually loading in like a whole bunch of documents with the scene map. If that was enabled, that is. Oops. Do we get more leaks? We have 1, 2, 3, 4 leaks. Or is it the same leak? No, I'm pretty sure it's like separate leaks. Token. Yeah, here's the issue with this fucking. Sorry, but it's like this goddamn parse, like JSON parsing thing. Okay. It's leaking here. Why is it leaking? What does it need to keep here? How is this leaking? I don't understand this. I don't understand because we're returning this previous, right, and I was sending it in here. And then we're destroying it here. So why is that leaking? I don't understand. Wait, is it because there's like an error or something? I mean, it might be. So there's an... Okay. So we... Oh, right. We don't... There's no error defer here. So let's do an error defer. Free preview. Okay. Yeah. That makes sense. Let's see if the other leaks disappear now as well. It feels weird. It shouldn't really, but maybe it only leaks because there's an error happening. What's this now? But isn't this pointer? Oh, it needs to be destroyed. Thank you, compiler error. Okay. Okay, we still get leaks, but we shouldn't get as many leaks. Okay, we fixed one leak. It is something happening with like array lists here, but it does probably come from JSON, yeah. And hopefully, if we fix, because I don't want to create an arena here because, well, actually, you know what? Maybe we do want an arena.